Hey, Chris, what's up, buddy? Hacked up Sunday. Let's go. How's PT going? Actually, doing pretty good. Going good on the recovery. I'm hoping soon. I got a couple more sessions left with my physical therapist, and then hopefully I can get back to actually exercising. Yeah, man. So, busy week. It's so funny because it feels like the weeks that are short, because I was off work Monday. We have that as a company holiday, and it feels like I just have still so much work to do this week. It's like it's not a shorter week, it's just a compressed week. Hope you can get back to progressing on finally recovering from the data loss in the homeland. Dude, I think we're just about actually recovered uh, from the code loss. Once I figured out that the lab range for some reason has a weird issue with the router, I think we're pretty much already recovered from it. However, we are hitting some new interesting issues where the execution path is basically just going off the rails. So instead, tonight, there's not much for the news. So we're going to do a little bit of news, and then we're going to do a little bit of HackBot. Oh, damn it, I didn't start the timer. There we go. Timer started. I've been randomly having VMware drop connections to the internet, and I have no idea why. Um, I'm gonna see if I can find something for you on that, Chris, and I'll show you once the stream starts. Well, it's an issue that you might come across, Chris, and it has to do with the way VMware handles networking on your computer. And I wish the iPad was working. I still haven't got it set up. I'm actually trying to spec out a second PC for streaming right now. So that way I can try and offload some of the stuff from this computer and try to stabilize it because this computer still gives me all sorts of trouble. It's baffling because I didn't touch anything, so I shouldn't have to set it up. Uh, oh, I should have just had to set up like InfoSec Pat taught. Yeah. It can get kind of funny because, like I said, I'll show you something here in just a second. I can show you the directions, but basically what happens is one of the VMware networking services on Windows tends to just crap out and get overloaded. And you can restart this one service. Uh, you restart this one service on Windows and then it fixes those problems. Especially if you're doing a NATed network with VMware. Yeah, it's a super fast fix too. Once you know what's going on, you restart this and then you're golden. Actually, what, you think it was the VMware, what is it? I'm trying to remember what it's called because I don't have VMware installed on this computer, but there's a VMware NAT service. And here, I'll type it in chat, something like this. VMware NAT service. It's a Windows service. Yeah, and you restart that. It can either crash or it can just get bloated and hung up. You restart that one, and 9 times out of 10, that'll fix your networking issues with like a VM not being able to talk out to the internet. There you go. What you do is you just open services.msc, Chris, and then you'll be able to find the service in there. Yeah. Like I said, it's simple fix, man. Simple fix. Not simple when you spend 5 hours researching it and can't figure it out. Dude, it's not just because you can't figure it out from the research doesn't mean this fix isn't simple. I was explaining that to Agent Zero the other day. Just because something's simple doesn't make it easy. And just because something's hard doesn't make it difficult, right? And so the example I used for him is like, how do you get a boulder to the top of a mountain? You pick it up and you take it up the mountain. Simple, not easy. Why did the intro song to the audio begin like the theme to Reading Rainbow? I don't know, man. I just grabbed a bunch of DMCA songs, and really it just comes from 2 playlists, but those are what I'm using because I got so tired of stupid alerts for stuff that should have been DMCA free, but on all platforms, but it was some on Twitch and some on YouTube, and it's just dumb. It's stupid. I got tired of fighting it, so I found some that I knew for 100% were DMCA free. Oh yeah, the timer's up. Let's get started. What's up, everybody? I hope everyone had an absolutely wonderful Wednesday. And I'm glad it is Wednesday, because actually I had my days all screwed up. I thought it was Thursday today. I was getting prepped to go do Thursday stuff, and then about 4:30 in the afternoon, I was like, oh wait, it's only Wednesday. Which is great, because I'm in the middle of a red team right now. It just started yesterday, and it's a really weird one, so the whole setup for it is taking extra time. Normally by now we'd have infrastructure and we'd have C2 payloads already done. Not the case with this one. There's a lot more going into it. So I was getting kind of concerned. I'm like, crap, I got to get this done tomorrow. And then I realized, oh wait, I have an extra day. Yes. All right, let's see. I picked out a couple of interesting news stories I wanted to cover. And actually, this one was from our good buddy Bobby Mac. He brought this to my attention. Or actually, no, I think it was Euler who did. And I hadn't seen this, but he brought it. He told me about it today. And this sounds actually pretty interesting. So apparently, the guys over at F5, they're big firewall and network appliance guys. They had some kind of a compromise and potentially a source code leak, from what I was hearing. I haven't read this. You guys read it along with me. I just get you my raw reactions to it. So I wanted to see what's going on here. So this was a F5 security incident, and it's marked from today. All right. We want to share information with you about steps we've taken to resolve a security incident at F5 and our ongoing efforts to protect our customers. In August 2025, we learned a highly sophisticated nation-state threat actor maintained long-term persistent access to download files from certain F5 systems. Now, I'm going to be real with you. Normally, whenever they say nation state threat actor, what they usually mean is just somebody we didn't catch. Now, it could be that they're just not going to go out and throw attribution out here and do that, but when I see sophisticated nation state threat actor, it very rarely is. Anyway, yeah, Void, we're talking about F5. Let's see. So what they did is they had downloaded files about certain systems, including F5 systems. So these systems included our big IP product development environment and engineering knowledge management platforms. We've taken extensive actions to contain the threat actor. Since beginning these activities, we've not seen any new unauthorized activity, and we believe our containment efforts have been successful. Oh, it was Scattered Spider? Nice. Void, do you know how they attributed this to Scattered Spider? Let's see. What did they also say? In response to this incident, we're taking proactive measures to protect our customers and strengthen the security posture of our enterprise and product environments. We've engaged CrowdStrike, Mandiant, and other leading cybersecurity experts to support this work, and we are actively engaged in law enforcement and government partners. Engaged with, I should say. We've released updates to Big 5, F5 OS, Big IP, Next for Kubernetes, Big IQ, and APM clients. More information could be about that. We strongly advise updating these new releases soon. Of course. I mean, that's usually a good practice. Oh, you're just pulling my leg. You have no idea about the attribution. Man, I thought you had some cool inside track. Break my heart. All right, let's take a look at this. What we know. At this time, based on their investigation of available logs, we confirmed that the threat actor exfiltrated files from our Big IP production development environment and engineering knowledge management platforms. These files contained some of our Big IP source code and information about undisclosed vulnerabilities we are working on in Big IP. We have no knowledge of undisclosed critical or remote code vulnerabilities, and we're not aware of active exploitation of any undisclosed F5 vulnerabilities. We have no evidence of access to or exfiltration of data from our CRM.
Caution. A virus has been detected.
Hey, it's Griffin!
Griffin virus detected in the network.
The Griffin virus detected in the network. What's up, buddy? Give you a shout out real quick. What's going on, dude? How's your stream going? Usually if you're right out this early, that means you got to go somewhere. You got things to do. I understand, man. But I hope you're having an absolutely amazing Wednesday. It's hump day. We're talking about a source code leak from the F5 guys. And Alex Dev, what's going on, dude? Oh, got to get your grub on before game stream. Gotcha. Understood, man. I got the guys trying to convince me to do some kind of a spoopy stream for Halloween, so I might break out this retro 1996 game for that. Looks like it was made for the Sega CD is the way it looks like. Alright, so let's back this up a little bit here. So what we're talking about is there's a networking company called F5, if you're not familiar with them. They make a ton of large networking appliances and systems for companies, load balancers, VPNs, all that kind of jazz. And so they had somebody come in, compromise their systems, and exfil some source code. So we're reading the incident response from this to see kind of what happened. Hey, no problem, Griffman. Yeah, I'll catch up with you soon, dude. So what they did is they confirmed that they had a threat actor. They exfiltrated some files, and that was from their Big IP product development environment and their engineering knowledge managed system. So they contained some of the Big IP source code information, and there were some undisclosed vulnerabilities in there that they were currently working on for Big IP. But as far as I know, they don't have any knowledge of a critical or remote code vulnerability that was being used in there, or that was undisclosed, or anything like that. Let's see. We have no evidence of access to or exfiltration of data from our CRM, financial, or support systems or iHealth systems. Which that's actually a really timely thing to report, that there's nothing coming from their support case managements, because that was how all the information leaked out of Discord, was they compromised their Zendesk. Let's see. However, some of the exfiltrated files from our knowledge management platform contain configuration or implementation information for a small percentage of customers, so we're currently reviewing these files and will be communicating with the affected customers directly. We've got no evidence of modifications to our software supply chain, including our source code and our building and release pipelines. This assessment has been validated through independent reviews by leading cybersecurity research firms at NCC Group and IOActive. Nice. Hey Kaiju, what's up, man? We're gonna do a little bit of news tonight, and then we're gonna do a little bit of HackBot, because I'm excited. HackBot is doing really cool things, but it's also doing really weird things. So the exploitation agent has caught back up to where we had the issue with the code loss. However, now it's doing weird stuff too. So we're able to recover what was lost, or at least reconstruct it, right? But then now it's gone off the rails. It's doing all sorts of weird stuff. It's breaking the exploit step queue, and it's getting nuts. So we're gonna have to go do a little bit more tender love and care on it. I've only used PyTorch a little bit, Kaiju. I haven't used it for loading a ton of models. It's been on my to-do list because my boss kind of wants me to bone up some more to become a subject matter expert on all things AI and machine learning, which I didn't. Not that I did not want to do it, it's just didn't where I see things going. But part of that thing is, okay, cool, I've already got a pretty good base on it. I actually have a blog post coming out about it tomorrow, and I'll throw a link up to Discord and on Twitter when that comes out. And it's called A Gentle Crash Course to LLMs. Because I think a lot of people misunderstand where the different pieces interact in a large language model. They think it's just the everything. I was like, no, really, the large language model is one small part, and you've got an entire web app wrapped around it, and you've got accoutrements and accessories slapped onto the language model, which is, like I said, really just a small probabilistic engine that happens in there. And that's where things get really awry. So I tried my best to kind of explain, hey, this is where things came from. There's a big, long history section in there. So to try and demystify a lot of what people think language models are. They think that they just kind of appeared out of nowhere and they're AGI and all this other stuff. So I went really deep into the history in there. But I also realized some people just don't give a damn about the history. So I broke it up into two parts. You can skip the history and just go to like the modern era, where I explain this is where we're at and this is where the security problems are happening. I'm really trying to get into training models. Dude, I really would love to. It takes so much power to train a model, though. It just takes a huge amount. There's this really cool one, Dante 7B. Let me see if I can find, from Outflank. Here, I'll drop this over in chat. But this was actually a relatively small model that they built. And I want to say, I forget how many training hours it was. I went through this exercise of I actually went through and figured out how much GPU time they had rented and computed and went through it. It ended up costing about $1,000 to train this model. And like I said, it's not a big model. It's a 7 billion parameter model. And it still cost them about $1,000 to go train that model from my estimates. So because they give you an estimate of how many GPUs they rented and for how long, and then you can just kind of extrapolate what's the current going rate for renting like an H100, which I think is what they used. And I came out to roughly $1,000 when I did that. No, Void. My manager's not asking me to come the SME of governance. And I thought it was actually really freaking funny because I keep getting emails from these guys who want me to do risk and compliance stuff for less pay than I'm currently making. I'm like, so you want me to do a job I hate for less money? Ooh, tough sale. Tough sale. I'm gonna have to pass. Let's see here. All right, let's go back to this F5 thing. What were they? So they didn't get a ton of source code. They got source code from the big IP system, which is, like I said, I think that one does load balancing and maybe some kind of IPS. I don't know the full feature set. It's kind of one of those things where it's like you buy licenses and plug and play the features. But they did get some of the source code from that. They got some access to support ticket items, but not the support ticket system. Let's see. What can you do? Nothing, because I don't have an F5. All right, so what are they doing, though? Let's see. We've taken significant steps to protect customers by remediating this threat and strengthening our security at the core enterprise and product infrastructure. Let's see. Since initiating our incident response efforts, we've rotated credentials and strengthened access controls in our systems, deployed improved inventory and patch management automation, as well as additional tooling for better monitoring and detection and response, implemented enhancements to our network security architecture, hardened our product development environment, including strengthening security tools and monitoring. And so think about this, guys. I mean, these are all good things to be doing, but when does this happen? It happens after some kind of excrement hits some kind of fast rotating wedge. That's when it happens. And so it's kind of funny because you might look at your IT security budget kind of like stable or dwindle down, and then you have an incident and bam, then it pops up. So it always kind of goes up in like a step function. It's kind of weird. It's almost like you're running a protection racket sometimes. Hey, Josh. Or Joe. Sorry, I read that as Josh. What's up, man? Let's see. I'm pretty new to this field, and I have a theoretical knowledge base in various contexts, like tactics, forms, data analytics, programming, networking, and pen testing. Nice, dude. That's a good cross-section in there. That's kind of what my background is. I have worked professionally in IT for 15 years now. I started around 2010, but I also have a degree in math, and I learned a lot about AI and machine learning, and I'm not at a super deep level. I'm actually trying to improve my knowledge in that respect to make it a lot more accessible for folks. But yeah, that's what I learned. Yeah, excrement plus fast-moving wedges equals trouble. That is right, Kaiju. But yeah, I just thought it was funny, like, hey, yeah, here's all the cool new stuff we're doing because we got popped. It's like, a lot of orgs, they kind of look at their security as status quo until something bad happens. Let's see. So they're going to keep doing code reviews for their products. They also partner with CrowdStrike and have Falcon EDR and Overwatch, threat hunting, big IP. Okay, yeah. So not a ton of stuff in there. I just thought it was interesting that this happened to F5, that they had this pop happen there. All right, I hate to do this, guys, but Peaches always has the worst timing on bathroom breaks. I got to go let her out. Give me like 30 seconds here. All right, I'm back. I'm back. Peaches always has the worst timing with potty breaks. Although, man, I had to let her out, though, because earlier today she was gassing me out in the office. I don't know. And I don't feed her anything weird. But she was sitting under my desk while I'm working, just ripping them. I'm just, oh. It's like just little tiny jabs in my nose. Pop. CrowdStrike, the two-time winner of the internets and such. I know, right? Good old CrowdStrike. All right, I wanted to take a quick peek at this because I've heard about it and I've been reading about it, but I haven't done really deep in this. So this is something called Crystal Kit that our good buddy, Rasta Mouse, put out. And so what does he do here? So this repo is a technical and social experiment to see if replacing Cobalt Strike's evasion primitives like Sleep Mask and Beacon Gate with the Crystal Palace position independent code, PICOs, I think that's what it is feasible or even desirable for advanced evasion scenarios. So what did he throw in here? Because there is a way when you're doing Cobalt Strike in the malleable C2, you can go set different staging options in here. Let me look at his blog post real quick. Hey, Mateo, thanks for coming online, man. Welcome in. I think we read this one. No, we didn't, because this is from October 12th. So this is his new blog post on it, because Rost has been doing a ton of work on a lot of the Crystal Palace stuff, particularly as it relates to Cobalt Strike. So, hey, Cypher, what's up, brother? All right. TLDR, repo here. Love it. Let's see. So the Crystal Kit is an experimental project designed to replace Cobalt Strike's Sleep Mask. Sleep Mask and Beacon Gate are the key to Beacon's runtime evasion strategy. For anybody who doesn't know, Beacon is what the little chunk of malware that Cobalt Strike makes that you would go use to infect a system and get command and control to it. It's specifically called Beacon. So you can hear somebody say they've got a beacon on a system. They might be referring to Cobalt Strike or some other C2. But if they're talking about beacon with the capital B, they mean literally the Cobalt Strike beacon code. Let's see. Not only does it mask Beacon's memory, it also acts as an API proxy for Beacon and other Beacon object files, BOFs. Which allows the operators to wrap supported API calls in a custom evasion function, such as call stack spoofing. That's so cool. I've got some guys that I work with that they just grok this like nobody's business, and I try to understand it. Eventually, I'll get to it. Part of the whole reason why I've been working on HackBot is because of the special agent loaders. That was actually a big driver for it, because as I go and learn new things about this, I have a way to go code it into a reusable platform that I can then say, okay, cool, now can I go crystallize the knowledge into a piece of code? So right now, HackBot in general, we're crystallizing the entire pen testing methodology into HackBot and letting it do its steps. Then all the specialty stuff we can put in the special agents, like we already did with the browser agent. Eventually there'll be, I've got to have one for Azure soon. Soon being, months. It depends. Depends on how quickly I get to the material. But a special agent that can go through and start checking out stuff for Azure. Anyway, let's see what he's got here. So in my view, the aspect of Beacon Gate that holds the most, holds it back the most is the limited number of APIs that it supports. So for instance, not supporting create process A means that any post-exploitation command that spawns a process, like shell, run, power pick, or execute assembly, are difficult to use when up against defenses that employ call stack analysis. So it also impacts process injection buffs because it doesn't supply that many of the APIs that are useful for novel injection techniques. And although not a weakness of the Sleep Mask directly, there's quite a significant gap when it comes to the runtime evasions in post-ex DLLs, since there's no Sleep Mask or Beacon Gate equivalent for the post-exploitation DLLs. There's no CS kit that ergonomically allows operators to implement similar evasive techniques for API calls. Yeah. So IAT hooking, what is IAT? I'm trying to remember. Can't remember. Oh, import address table. Yeah. IAT hooking is a technique that's been shown in the past by reflective loaders like Titan Loader and Ace Loader. So the strategy is to inject a position-independent code. That's what a pick is. A pick blob into memory and hook the IAT of the DLLs as it's being loaded. The hooked APIs are redirected to the pick blob, which performs the evasive development by the author. Nice. By the way, this is all talking about this system called Crystal Palace, which I will drop a link to for here. It's a really cool thing. The guy who wrote Cobalt Strike is the one who put together the Tradecraft Garden, and Crystal Palace is a part of that. Let's see, Crystal Palace is specifically designed to load multiple resources as picks and provide conventions for accessing them as symbols in your code. Nice. That greatly reduces the burden on the developer to get all these components working with each other. Two interesting samples include the garden, simple hook, and stack cutting. Man, I wish I hadn't stopped with binary exploitation when I was doing it in, must be about 2010. I wish I just kept on with it. Anyway, that's in the past. The hooking sample shows how the Pico can hook the IAT of the DLL to mask or unmask memory before and after an API call. And the stack cutting sample shows how a hooked API can be pushed through a pick that implements a call stack spoofing technique. It's so cool. I love this. Eventually, actually, I was thinking about once the exploitation agent for HackBot is really stable I'm going to talk to Cody. We'll have Cody come on the stream, and we're going to start planning out. I'm going to start planning out the post exploitation agent ahead of time. But we're also going to have Cody come on and talk about Mythic C2, because there's a lot of stuff in the back end that I know I personally have friends that are curious about. I know a lot of y'all have using Mythic C2, and when he comes on, he's going to be up for answering questions, and we're going to have a discussion about how we actually want to handle it. And we're going to see, hey, what would be the best way for our agent to go interface with Mythic and do things. So it'll be a lot of fun. So much fun. Cody was the first interview ever that I did. And he's a great guy. Let's see. So what does the crystal kit provide? So a prepended reflective loader. Nice. A pick stub that performs call stack spoofing. Pico that hooks the DLL's import address table. And an aggressor script that registers the relevant hooks in Cobalt Strike. Very cool. Let me go look at that real quick, actually. So what has he got in the CNA file here? So just for anybody who doesn't know, a CNA file is called an aggressor script, and this is in an absolutely horrendous language called Sleep. But what it does is it allows you to basically make custom commands for Cobalt Strike. Hey, Monkey, what's up, dude? Let's see. So what does he have in here? He's got beacon gate stuff, post-X RDLL generation. This is a lot less than I was expecting to see. So he loads up the beacon and the arch. Let's see. Loads up a loader spec. Okay. I understand some of these commands. I have no idea what he's actually doing here. I'm going to save it, though, because I'm going to save it for further investigation. So I'm going to put this over in the malware, the maldev kit over here. So if you want to see where this list is, guys, just go to the BlaiseBits GitHub. And then come over to stars. And then here is this kind of, all these lists I'm kind of curating for different things in here. So malware development, red teaming, interesting developer tools, research, stuff like this. I love Cobalt Strike. Manny, I loved Cobalt Strike. I really liked it until I used Mythic. Cobalt Strike still has some benefits to it. Don't get me wrong. It's not like it completely is overshadowed by Mythic. However, I really like Mythic C2. I don't care what anyone says. Cobalt Strike's bae. Yeah, I really do like Mythic. Part of the thing that kills me about Cobalt Strike is I could be on an op and doing things, and I could have like the most amazing find in there, and then if my Cobalt Strike client dies, then my evidence for my report is gone. Ugh. Oh, it hurt my heart. So that was one of the biggest things I loved about Mythic. Yeah, being able to bring your own agent? Yes, exactly. I may, in the future, create a custom agent for Mythic for HackBot, and it would be purely an academic exercise. It would not be anything to use like on an actual penetration test or even like a CTF. Actually, I take it back. It'd probably only be good on CTFs. Yeah. All right. I had one more interesting news story, actually, before we divert back over to HackBot. So like I said, it's a pretty light news night. But this one was kind of interesting. And especially, I think it's really relevant right now because I know a lot of people in tech are on the job hunt. So I wanted to bring this one to light. How I almost got hacked by a job interview. I was 30 seconds away from running malware on my machine. The attack vector? A fake coding interview from a legitimate blockchain company. Now, I don't know of anybody that's a legitimate blockchain company, so I'm gonna take that with a big old tablespoon of salt. Here's how a sophisticated scam operation almost got me and why every developer needs to read this. So what was the setup? Last week, I got a LinkedIn message from Mykola Yanchi, Chief Blockchain Officer at Simfa. All right, anytime I see Chief Blockchain Officer, that's going to set up a red flag. I'm just being real. Anyway, but he claims real company, real LinkedIn profile, thousands of connections, the works. The message was smooth and professional. We're developing Best City, a platform aimed at transferring real estate workflows, part-time roles available, flexible structure. So I've been freelancing for 8 years, built web applications, working on various projects, done my share of code reviews. I'm usually paranoid about security, or so I thought. It looked legit, so I said, yeah, let's have a call. Chief Imagination Land Officer. Yeah, exactly. So check out the hook here. So before before our meeting, Mykola, sounds like Ricola. Mykola sent me a test project, standard practice for such an interview. It's a React Node code base to evaluate my skills. About a 30-minute test, simple enough. Big Bucket repo looked professional, clean README, proper documentation, even had a corporate stock photo of a woman with a tablet standing in front of a house. Here's where I almost screwed up. I was running late for our call, had about 30 minutes to review the code. So I did what lazy developers do. I started poking around the code base without running it first. That's not being lazy. That's being prudent, dude. That's wise. That's wisdom there. So usually I sandbox everything, Docker containers, isolated environments, but I was rushing. I spent 30 minutes fixing obvious bugs, adding a Docker compose file, cleaning up the code, standard stuff, ready to run it and show my work. Then I had one of those paranoid developer moments. So before hitting npm start, I threw this prompt at my Cursor AI agent. And the prompt was, before I run this application, can you see if there are any suspicious code in this code base, like reading files it shouldn't be reading, accessing crypto wallets, etc. And holy bejesus, sitting right in front of, right in the middle in the user controller's JSON was this beauty. And what do I always tell you guys? Before you go download something and run it, you should go read the code. And if I saw this weird, okay, this is weird for a number of reasons. One, this is a constant byte array with nothing in here. And why the heck does this, I'm assuming that this was actually the code. Let's assume this was the comment in the code. You don't need a constant byte array in code to go do any of this. And so it's coming through and it's like, why are you making a response to go get this code? And then on top of that, this is put into, I think it's called what is it? Iffy. This is code that basically doesn't do a function or anything. It's like a self-instance execute. Is that what it's called? Iffy. Immediate invoke function expression. Yeah, an iffy. Right here. So this guy just gets fired off immediately and goes. So this would have raised all of my paranoia alarms. If I saw this and I was reviewing some code, constant byte array being executed in an iffy, why would you even do this? Because there's no code coming back and forth. It's all contained inside here. It's a contained function call. So he said it's obfuscated. Yeah, not really. Evil and 100% active. So embedded between legitimate admin functions ready to execute with full server privileges the moment the admin routes were accessed. So I decoded the byte array and it went to this web address here, something on endpoint.io. What is endpoint? What is this? JSON web storage wins that won't break your app. Huh. I hadn't seen this before. So when I hit the URL, it was live. I grabbed the payload, pure malware, the kind of steals everything, crypto wallets, files, passwords, or your entire digital existence. But here's the kicker. The URL died exactly 24 hours later. So these guys weren't messing around. They had their infrastructure set to burn evidence fast. Now here's the thing I don't get. If 24 hours is a pretty long window here, I was like, wouldn't you maybe leave that up for longer? And that's kind of weird. Or even then, there's a lot of other OPSEC things you could do with it. I'm not going to go into that, but that is actually interesting though. That hey, it was up for 24 hours and then bam. So, and also they said it was up for 24 hours later. Like he's implying that he accessed it and then 23 hours, 59 minutes, 59 seconds later, bam, it was gone. A little bit funny, but I get where he's going with that. Yeah, it looks like it's Java. It looks like it's like paste bin for JSON. That's what it kind of looks like. Create a JSON bin. Yeah, pretty much. Store JSON online, lock the schema, edit with a friend. Yeah, so it's like it's paste bin for JSON. That's what it looks like. Yeah. Hey, Hats, what's up, dude? CPO rings quite the other bell than blockchain in my ear. Think of bovines. Yeah, right. So it's browser-based. Would it not be cached anyway? I mean, it could have potentially been cached, but only if somebody requested it or it was going through a caching proxy. That's the only time. Well, he's already got the... I mean, he's already got the payload. He saved it. He downloaded it. But let's take a look at the operation here. So this wasn't some amateur hour scam. It was pretty sophisticated. So the LinkedIn profile for Mikola Yanchi looked 100% real. The chief blockchain officer, that's 100% real. Doubt it. Had a proper work history, even those cringy LinkedIn posts about innovation and blockchain consulting. The company, Simfa, had a full LinkedIn company page, professional branding, multiple employees, posts about transforming real estate with blockchain. They even had affiliate pages and follower networks. So the approach also had no red flags in the initial outreach. It was professional, reasonable project scope. They even used Calendly for scheduling. That's a nice touch. That's kind of a weird thing. So I was thinking about this because actually I did read through this one earlier today when it came across my my awareness. And this is a lot to be put up. This may actually be a legit company and they're doing this. They might have compromised this guy 6 ways to Sunday and he doesn't even know it. And they're piggybacking off of that for this. This is a lot to set up to maybe just scam a couple of crypto wallets off of some developers. And the reason I say that is because a lot of developers are going to be smart enough not to leave their crypto on their primary system. They're going to have a couple of hot wallets in there that may have a few $100, right? That's what happened with the NPM hack a couple of weeks ago. Yeah, it hit a few developers, but for all intents and purposes, when they backdoored the, what was it, debug package, they only got about $1,000. That was a huge hack, and all they got out of it was $1,000. You know, good job, GFY. Let's see. What else do they have here? Okay, so the payload. The malicious code was positioned strategically in the server-side controller, ready to execute with full Node.js privileges when admin functionality was accessed. Yeah. That actually, I thought he did a pretty good job of thinking about this too, the psychology of this attempted attack. So there was a sense of urgency. Hey, you got to complete this before our meeting to save time. There was some sense of authority because it was a LinkedIn verified profile, real company, and it looked professional. And there was some familiarity to it. So it wasn't outside the comfortable zone, right? Standard take-home code test. Every developer has done dozens of these. And also there was some social proof to it, like some backing. Real company page, real employees, real connections. Almost fell for it, and I'm paranoid about stuff. Not paranoid enough, bro. So the lesson here, one simple AI prompt saved me from disaster. Not fancy security tools, not expensive antivirus software, just asking my code assistant to look for suspicious patterns before executing unknown code. Yeah, I believe that. What's the scary part? This attack vector is perfect for developers. We download and wrote code all day long. GitHub repos, NPM packages, coding challenges. Most of us don't sandbox everything. I would. I do. All the stuff I even got for HackBot is on a sandbox system. And what I think is funny is actually somebody brought up, because this came to me through a Twitter thread, and on there they said, hey, this guy messed up. He could have done this so much better. And that is, he could have just had this in a sketch NPM package that no one uses except literally this code project. And as soon as you did an NPM install, bam, post install script, you're pwned. Let's see. And this was also server-side malware, full Node.js privileges, access to the environment variables, database connections, yada, yada, everything. I use AWS Q with VS Code. I messed around a tiny bit. Actually, I have Continue set up on PyCharm on a different computer for stuff that I'm just trying to turn out and not learn about, right? So when we're writing HackBot, everything for that I'm doing myself except for 2 pieces of code in there. And one of them I'm going to completely rewrite because it's way over engineered. The other part, it was AI inspired, but actually I wrote it. I just couldn't figure out the proper structure. And I think I used Grok for that one to help out with it. But for the most part, I don't use a coding assistant. I probably just literally use it more of a convenient way to have a language model accessible inside the IDE so I don't have to switch over to a browser. That's the way I usually do it. All right. I think this is about where I gave up when I was reading it earlier, so let's check this part out. So if this sophisticated operation is targeting developers at scale, how many have already been compromised and how many production systems are they inside right now? True. Let's see. Developers are the ideal victims because our machines contain the keys to the kingdom, production credentials, crypto wallets, client data. Dude, why do you think whenever I'm doing a penetration test, I always target the developers? I like to target two main areas: developers and security people. Because developers suck at security, and security people get so burned out they ignore security. Those are the two I go after. Let's see. I'm gonna argue against this one. Multi-layer obfuscation, remote payload delivery, dead man switches, server-side execution. This isn't technically sophisticated, especially since he goes and uploads the malware payload over to VirusTotal and it gets flagged in there. So I mean, I'm not technically sophisticated. No. Socially sophisticated, yeah. I'll agree with him on that. One successful infection could compromise production systems at a major company, crypto holdings worth millions, personal data of thousands of users, right? Better hope your devs are working on their own system. So the bottom line here, always sandbox your code. Yep. And people give me crap about liking Docker a lot. No, I like Docker because it sandboxes and gives me a clean execution environment. It adds many things to a project. Use AI to scan for suspicious patterns. Not always feasible. Large code base, you're going to choke on it. Anyway, verify everything. Real LinkedIn profile doesn't mean real person. Real company doesn't mean real opportunity. True, I'm not going to, me personally, like if I was in his position, I'm not going to go through the trouble of a coding challenge until I at least talk to somebody for 15, 20 minutes. Even that is still suspicious though, because there's lots of AI voice cloning now. Damn, I just remembered I got a project I got to go work on about that. Anyway, enough on that later. Number 4, trust your gut. If somebody's rushing you to execute code, that's a red flag. True. Don't run untrusted code. Don't. Balmer. Developers. Yeah, right, monkey? One other thing that's good is we say... Hold on. Other thing it's good with is, let's say you write save settings function, you can ask to generate load settings, and mostly it would be right on the spot. Yeah. Oh, sorry, I missed your previous one. So I do use Copilot with my code, but I use it to say, let's say, translate my C structures to Python C structures and so on. Yeah, I'm not using it to go structure my code. I'm using it for like, crap, how did I do that again? Or what's the best way to like maybe make this kind of function? Stuff like that. But this is actually something also I didn't look at earlier, which is, he has some nice screenshots of the actual... Can I zoom in on that? No. I'm zoomed in more than it's going to zoom in. Hold on. That's a horrible zoom in. There we go. Let's see here. So here's snaps of the LinkedIn profile. Simfa. It's really tiny. Harnessing the power of AI and value-driven R&D to move insurance forward. Yeah. Sure. Let's see. And then here's the guy. Here's Ricola Yanchi. Blockchain innovator, chief blockchain officer, building the future of crypto databases at crypto.com. Wait, is crypto.com still in business, right? I'm trying to remember. Yeah, they're still up. Okay, hold on. If he says he's this stuff at crypto.com, that should be pretty easy to verify. Why is he still saying he's at crypto.com, but now he's at Simfi, right? Let me see. So that's one of the other oddities that I would have flagged on. It's like, hey, how come if you're the chief blockchain officer, don't you think you'd be plugging your own company rather than one of the other ones? It's not a super big red flag, but a lot of little red flags add up. Chief blockchain officer. Let's see. So what are the messages? Let's see. Schedule a meeting with Calendly. Here's the test requirements. Got a Google Doc. I mean, it looks fairly good. Although I'm going to be hella sus if anybody just like right off the bat sends me a link. Just to be real. Especially if you're using, okay, this is hot garbage AI generated right here. That would give me immediate pause too. So I think this guy could be properly paranoid, but I do believe he could be more paranoid. So up here, I guess that was the actual source code for it. But he had, he had a link to the actual malware analysis. He just threw it up into an automated scanner. Where was that? So I did want to go take another look at that. Here it is. Yeah, he threw it up in VirusTotal. AWSQ might be able to read that large a code base, but I would not rely on it. Yeah, no kidding. Like I said, these guys, they probably had a better opportunity to obfuscate this stuff, and I guess good for us they didn't, or good for that guy. Let's see. So MITRE attack tactics, execution. Found a WSH timer for JavaScript or VB script to try and be evasive, probably. Let's see. What about defense evasion? JavaScript file with very long strings to be likely obfuscated. Let's see, what else we got in here? Discovery. Checks available memory. That's actually probably, this check available memory, that's probably to see if it is in a sandbox. Which would be weird because it executed in their sandbox. That's usually one of the things that, if I'm building a payload and I want to make sure it doesn't get executed in a sandbox, check the memory. If it doesn't have more than 4 gigs of memory, then you're probably in a sandbox. Let's see, so what else we got here? Defense evasion. They flagged it as rootkit. Hidden file directories bootkit? No. Create file. Yeah, persistence. Hidden files and directories. Bootkit. Hold on. Is this just going to the definition of the bootkit? Yeah, okay. I want to see where they were actually hitting this. So for DNS resolutions, they go to some GCDN and something from Fastly. And so all the things it's accessing are some Microsoft Network downloader, Windows Search Neural Network, neutral. I don't know what that is. But they did write this file right here, this download1.temp, accessed a whole bunch of registry keys. Let's see. So they looked at the JS file script engine, and in the script host, these might have just been accessed as part of attempting to execute the what is it? The JavaScript payload, basically. Not the JavaScript like in the Node.js, but the JavaScript on like Windows side. Bootkit and JS, please stop threatening me. I know, right? Let's see. Because, yeah, it looks like what they did is it downloaded a temp.js and then tried to WScript execute it. Now, it's weird that it says process is created LSASS. This is probably just a weird artifact of the malware execution sandbox. That's kind of weird. Shell commands, let's see. Edge update service. Let's see. LSASS, yeah. So he's talking about it's nasty. I was like, I've seen worse, bro. Now this is weird though, because this is just the process tree. Okay, so this is the process tree here, but this is the only one that's important. This is what's going on here. Yeah, WScript from C users user desktop gem. Yeah. So interesting stuff. Interesting. Not super technically sophisticated, but there's actually another thing about this. So this, like I said, came to me from an X thread over here, or Twitter thread, or whatever you want to call it. And this guy posts about it, links to his blog post about it. But there's so many other people that reply back like, yeah, dude, I had the exact same thing happen to me. Someone hit me up with a job for a good coding challenge. Seemed weird. Uploaded it to Gemini 2.5 Pro and checked for the analysis. Had a malicious backdoor triggered in department's module JS. Damn. One of these guys said, I was just targeted with something even sneakier. I broke it down in this tweet here. Let me see what he had. Let's see. So I was targeted by a developer-focused malware disguised as a MVP to review prior to call from a Bitbucket repo sent by someone who looked semi-legit on LinkedIn. So he gets a message saying, hey, hope you can maybe work on our job, full-time contact, you interested? Someone who claimed to be a business assistant for a software studio messaged me about a blockchain game dev role. Dude, it's always blockchain, man. Offering a salary in line with the industry seemed relatively normal. I'm curious, what is the salary in blockchain now? I was like, I get it that there's some, but it ain't like the 300, 400, 500,000 that it used to be. Surely not. Anyway, so they had 3D crypto chess. Oh, that's sus as hell, man. So instead of running it, I decided to dig in to see what was going on. It was seemingly benign Node.js Express React, but hidden somewhere were the malicious objects. So there was a obfuscated JS file, and there was an eval function on a remote fetch code. Ooh, interesting. So if I had run, let me see what this said here. Here's the MPV version. Sends me the link. Can you check it and let me know when you're available for the CTO? Okay. So this is just them conversing. So if I had run the npm start on my local machine, I would have executed installation of malware. So potentially stolen cookies, botnet, full control, all that jazz. So in the utils.js, that's loaded automatically from the app.js, it fetches code from a remote URL, tricks, this is a trick in the error handler, which actually executes the code using function constructor trick. Let's see if I can blow this up. Let me see. So there's a constant to a host to a Vercel app. So he's going to try this, and then there's the error code. Interesting. Hold on. So why is he setting this like this? I'm trying to understand what he's actually got going on here. Side rant. I've been fighting getting Nginx proxy manager up and running. It just would not let it would not get a Let's Encrypt certificate no matter what. Finally got an LLM to identify the permission was set on the root instead of nobody. RIP. They are useful for troubleshooting some things. I'll give you that. I'm trying to see. I'm just curious what this code is doing here. So require error code. Hold on here. So it looks like he's trying something. He constructs a response. He waits for this. Maybe it's designed in such a way to trigger the error, and then this gets stuck in the error. Error handler, let's see, error.message, error response, data. So I guess it'd depend on whatever's in this error handler here. But it looks like, if I'm guessing right from this, it looks like it's actually trying to potentially download this information. It shunts it over into this error object, and then it sets a new function constructor called require for what gets come back from the error code. So it kind of injects it into require. That's hella sneaky. That's way sneakier than the blog post we read. Let me see, what do you say? So the trick is the error handler, which actually executes the code using the function constructor trick. Oh. So another oddity, looking at the package.json, the output from the node server is piped into the running front end. So this would start both apps, but at a minimum, hide logs from the server by piping them to the front end. That's wicked. That's wicked, bud. So those were just a couple in here. There's a ton in here of like people like, yeah, this happened to me. This happened to me. I almost got hit with this. Oh, crazy. Crazy times. Blockchain games, because everyone loves those. Must be a great market opportunity there. So how many NFTs do you guys have? I have approximately, it's a nice round number. I think, the Mexicans call it cero. Let's see. So I'm having some difficulties implementing best practices in respect to properly setting up a VM and a test lab, isolating a sandbox, and getting Kali officially downloaded. Any tips? So Joe, it depends on kind of what you're running with, if you're running with VMware or if you're running with VirtualBox. But for the most part, if you're just building a little test lab and you're not going to be messing with malware, there's not really too many best practices for that. In fact, I encourage you to go tinker around, figure out what breaks and what doesn't, and then encourage you to figure out why it broke. If you have another computer on standby, like anything roughly conversive, just like a regular desktop, there is a really cool program that I love. And it's a double-edged sword. It can be really great for helping you understand stuff, but it can also hold hand you too much if you rely on it and you don't figure out what it's doing. But it's this system right here called Ludus. This is actually what I use to run my home lab here. Yeah, I'm going to drop the link. I love Ludus. Ludus is fantastic. Wait, hold on. That didn't send over to YouTube. Hang on. I'll drop it over here. There you go. Ludus. Ludus is really cool, and it makes it so where you can basically define your test ranges as software. So you just define them in a YAML file. Let's see. Is there an example one? Yeah. This is an entire computer layout once you have Ludus up and running. And it's really easy to get running. Pretty much you install Debian onto a server, Debian 12. You download and run the Ludus installer, which usually you can actually just do with a single curl command. And then once it's up and running, there's a few more steps to kind of set up your virtual machine templates. And then this is it. This is a network right here for a very small Active Directory domain. Gets you a domain controller, gets you a workstation, sets up AD, joins the workstation up to the domain controller, and you're good. And you can make all sorts of really awesome labs with this. I really, really like Ludus. They're getting ready for the 2.0 version to come out too soon. Hey, Fo, what's up? Let's see. What do you think about root authority anti-cheats? I'm not familiar with the root authority. Do you mean like kernel level anti-cheats? No, Ken, that was not a show called I Love Ludus. Yeah, Ring Zero and kernel level anti-cheats, not a fan. Especially not in games where it's kind of dumb to have them. Like maybe a co-op game where you're just trying to spread democracy. There's no reason to have a kernel level anti-cheat in a 100% co-op game like that. And then on top of that too, I just don't like anything running the kernel. In fact, because of the stuff that CrowdStrike did, Microsoft is currently in the process of kicking everyone out of the kernel. So if you're not familiar with what happened with CrowdStrike, you probably heard about it, but maybe just on the periphery. So CrowdStrike is actually a really good endpoint detection response system. Think of it like an AV on steroids, right? You have AV and then it's Big Brother EDR up here. And they basically did not validate the update that they were sending out. And that CrowdStrike update went out to, quite literally, and as everybody remembers from 2 summers ago, millions of computers. So that one update took down a large chunk of the entire internet, right? Hotels, airlines, hospitals, you name it, because they were all running CrowdStrike. Well, CrowdStrike, because of that and because of the way it shims into the kernel really early in execution, so it can try and catch some bad, malware. Because of that, Microsoft is like, okay, all of y'all out of the kernel. They're taking the Mac approach. Mac will not let you in the kernel unless you exploit your way in there. Windows is kind of like, oh yeah, you got a driver? Come on into the kernel, buddy. And so, not a fan of kernel level anti-cheats whatsoever. There are ways to get around it, but typically you're either doing some really deep exploitation, and I know it can be annoying. I know it can, believe me. The ways that you get around kernel level anti-cheat is ways that are probably going to get you caught, but also there's other hardware ways to do it, where you can literally just plug in a hardware appliance and get memory bus access. People are always going to find ways to cheat, and the way you identify them is heuristically. You look at them and you say, okay, yeah, this person is doing certain things that they should not be able to do unless they have omniscience or something stupid like that. So, long story short, yes, not a fan. Anything Ring Zero should be non-critical stuff. Yeah. Hey, no problem, Joe. That's a problem. Not a problem, man. When I put Q&A, I think I put Q&A in there. Yeah, when I put Q&A in the stream title, I mean it. I 100% mean it. You can ask any of the folks that have been watching for a long time. I have zero problem derailing the stream to try and help somebody out if I can. If I think I can help you, then yeah, we're going to jump to it. If I don't, then I'm going to try and point you in the direction where you can find the help that you want. Ads, I couldn't hear your response. TLDR, kernel level anti-cheat sucks. I don't like it. Shouldn't be on some games. Should be used as an exception, not the rule. Can confirm he's given up on me. I have not given up on you, Cypher. Oh crap, I just realized something. I was getting ready to start up HackBot except I haven't booted up the lab box. Let me go deploy the test machine. Stop it. There we go. Let's get this booted up so we can go do a seed run real quick. And I want to see what's happening because we had some really weird behavior. And I apologize. I would normally diagram this out, but my iPad died. And so, but what was happening here is as HackBot's going through and executing, attempting to do the CTF, it's basically building a task queue. Right now, we see the task queue with all the tasks it needs to do, and it's just kind of iterating over that list. When it gets over to exploitation, though, exploitation, we give it the top level task, which is, hey, go get a web shell on that system. And then it fills in all the gaps down to what I call exploit steps. So we have a, let's call it like a primary task. And let's say the task was, hey, go exploit that box. Then the exploitation agent actually looks at it and goes, okay, I think this is how we could do it. Let's go try and get a web shell. Cool, we get the web shell. That is an exploit task. So we've got a regular task, and then there's a distinct different kind called an exploit task that nests under that. And then inside that exploit task, there will be exploit steps. So as we're tracking these things in our state table, it gets kind of deep. There's a lot of relative values we have to account for. P44, what's up, dude? I hadn't seen your beautiful name in a while. I hope you've been good. I hope you've been doing good, man.
Bullshit, I can't hear you. Sound off like you got a pair.
Gumby, you're so full of crap. Joke's on you, I use Linux. Oh, I'm getting so fed up with the idea of Windows 11. Like I said, I'm actually looking at potentially setting up a computer dedicated to just to streaming so that I can shunt everything off over to that and then put Linux on my primary driver. All right, let's go seed this sucker real quick. Let's go over to Stinger. There we go. So for anybody who hasn't seen it, this is what HackBot currently looks like. So each of these nodes, except for these ones here with these little stacked squares, these are actually sub-agents. So this is the overall Stinger supervisor agent. These are called the primary agents. And this is what actually does the different phases in here. So when we're going to seed it with this input here, we're giving it this content, which is simulating a human message in, let's say, like a language model chatbot. That gets piped into human input. The initializer comes through and says, okay, let me go ahead and convert all of those into tasks. And then Stinger right now has no intelligence to it. It's just divvying out the task and passing command execution down to the primary agents as they happen. So what we're doing right now is we're seeding it to go through the entire attack path right now until it gets to the exploitation agent. Then we can actually start working on it because it'll take a snapshot of the memory, save it as a pickle file, and then we can reload that every time we successfully run the exploitation agent. So we don't have to run the entire workflow again. I'm pissed about the Windows 10 end of life, Windows 11 push. Let's see. But I have a ton of, oh, sorry. I was trying to understand, again, a typo in there, but I have a ton of hardware development, special apps, and CADs I need. Yeah, I know, right? Oh, so you've been finishing the CPTS report and have 13 out of 14 flags. Nice, man. Get some. That's good, dude. I've been doing really well, man. I'm on a red team assessment right now at work, and we're getting ready to put together a nice little sneaky squirrel payload. And it's going to be a little bit of a pain because the infrastructure that we normally would set up for something like this, it's in this weird kind of bifurcated setup because we have a special requirement for this client. So it's kind of weird because I can't rely on a lot of the automation that I normally have for setting up that infrastructure. I've got to kind of automate it in one place and then migrate by hand over to another. So it's adding a little bit extra trouble to it, but it's fine. We'll probably have our initial access come Friday, and then we'll have a couple weeks to actually work for the client, get our objectives, stuff like that. So the setup factor directory as for managing cert adding snippets using Serve Wizard, as well as configuring network properties to configure the network to add an IPv4 double for DNS set. I think I got that right, Joe. Hold on. Let me see what else you had in here. Oh, Codevex. Hey, I just saw your message. Welcome in, man. I hope you're having a wonderful Wednesday. I hope everybody's having an absolutely whimsical Wednesday. Let's see. I wonder if there's something like Parallels Desktop, but on Linux, not Mac, that emulates Windows and shows the window only to support multi-screen solid. I haven't seen anything like that. That kind of functionality for Parallels. I've only kind of seen outside of that with, crap, what was that called? Citrix. And you don't want to mess with that. Friends, don't let friends use Citrix. Could I convince you to get a chat combiner overlay with YouTube and Twitch? So Twitch is really actually they're pretty weird about that. I know a lot of other streamers do it, but there's also been reported cases of streamers getting banned for that. It's really dumb. Like, for example, on Restream, you could have combined like Twitch and YouTube, and I think maybe even TikTok on there. And I've thought about it. Maybe I probably should, because I mean, I see Primogen doing that all the time, but also I'm not Primogen in many, many ways. For one, I have a glorious beard. He actually has programming skills. You know, we're different. I work in a hospital. We extensively use Citrix. I'm aware, and I'm sorry. Oh, let's see. How big are the pen test reports usually in the well? It depends on what you find in there. So I've had a few clients during my time where I literally had nothing to report. They were really on their game, or I just didn't find anything to exploit. Sometimes it's just a numbers game, and the environment could be really big, and you just happen to not find where the weakness existed. And in those cases, typically what you're doing is you're writing an explanation of all the activities you went through and why certain events did or did not happen. But for the most part, as you're writing it, the length is typically directly proportional to how much you find. And that's usually, in a lot of cases, depending on the client, pretty proportional to how bad their environment is. So if they've got a really bad environment and you're on a short time frame, you still might find a lot and have a really chunky report in there. Cypher, I am sitting right here. I'm not pooping right now. Primogen has a bouncy ball, you code from a toilet. Very different. I'm not. This is my chair. It's a chair. There's no porcelain here. There's no porcelain here. Freaking trolls. Oh, I think the biggest penetration test report I ever had to write, I think came out to close to 200 pages. And it had so much on it. It was huge. So typically in a penetration test or a red team report, what you have is you have your typical boilerplate executive summary, explanation of the like a brief description of the findings, and then typically you go into some kind of a narrative narrative section in there that explains, hey, this is how everything evolved and what we did over time while we were in your environment. And then you go through and you explain that and kind of what the impacts are. And then afterwards, you have like a detailed breakdown of the issues you observed, usually whatever you call them, findings or whatever. They're typically always called findings. Then you have a breakdown of those. And usually we used to call those the tear sheets, because back in the day, when you'd actually go print out the pen test report, the idea was the person who's going to be responsible for doing that is going to just rip that portion out of the report, tear it out, and give it to the tech so they can go fix it. This should have been done a while ago. What the heck is going on? You know what's going on? Is me. I have, without a doubt, the smoothest of brains. This thing is so smooth, an ant could fall off it. I didn't turn on the VPN. It has been sitting here spinning its wheels, trying to get into this thing. Damn it. I'm like, this sucker should have been done a long time ago. Like, we've been talking for a minute. No porcelain? That's an extra fancy toilet. That's right, carbon fiber. Carbon fiber and fabric mesh. It's a hell of a thing to clean up. How much did that cost me? Shoot. Now, I can give you a rough estimate, but this is never correct, this price analysis here. Because, like, this is saying it costs about 20 cents, I think. Right here. Or it's actually saying this cost about 22 cents to do this run. I haven't had a run cost me that much, and as many runs as I do, I would have burned through my Anthropic tokens by now. I've only used about 40% of them. So, and I think 40% is a high estimate. So, I like the idea, but these cost estimates are pretty much overinflated. How many tokens is a run usually? Let me go see, actually. Well, actually, when this one finishes and it completes everything, let's see. Did the in-map scan actually return the proper data instead of just saying everything was down? Yeah, it looks like it did, because we got SSH data back from here. We'll see what this one says whenever it's done. That'll give us like a rough estimate here. Right now it's doing GoBuster to brute force the directories. I want to say typically, we can look at this one here. Usually it looks like it burns about 100,000 tokens currently per run. And it's skewed to about 2/3 input, 1/3 output tokens, which is about right because we're constraining the context and we're trying to tell it, hey, be brief, get to the point, don't elaborate. I don't want a story, nor a novel, nor even a couple paragraphs. Just get to the point whenever you return this. Hey, Vandal, what's up, man? He's going broke over how many scans he does. I know, right? How many? Ah, damn it. I can't check it over here. Hang on, actually. One sec. Let me pop into OPSEC mode. And I think I can tell you. Let me see. I'll tell you what I've got left. We started with $100 worth of tokens over on Anthropic. I got that a while ago. Let me see how many we've got left currently. Let's see. Remaining balance. Oh, maybe I am burning more than I thought. Remaining balance is now 44. It was like 65 a couple months ago. Oh my. There's a bunch of invoices in here. Hold on, what was the last stream at? The last stream was on the 11th. Let me see if I had an invoice for the 11th. No, I didn't. That's right. Let me look at the October 1st invoice. How much did they invoice me? So for the month of October, looks like we spent 16 bucks. 16 bucks working on it during the month of October. So, not such a big deal. You have 34k tokens on this scan so far. Actually, we're up to 81,000 so far. And like I said, the previous example, it went to 100, but also that previous example didn't have all the fixes we put in for the exploitation agent. And the exploit agent can get stuck in a pretty hard loop over here. Right now, it looks like the browser is trying to actually upload the PHP payload. Let's see, what's it uploading? Yeah, so it's trying to upload webshell.php. So it hasn't gotten to the exploit bypass yet. Oh, there we go. So it's going to rename the file. We're going to rename it to webshell.phtml. Nice. And then it's going to try and redo the upload. Actually, if it chose PHTML, it's actually going to work. The problem that was happening last time is it was picking these weird funky extensions. It was trying to like do a double extension of like .php.jpg, and it was getting confused about that. So it got kind of weird when that was happening, but we'll work on it. We're going to work on it. We're going to try and tighten it up a wee bit so it doesn't go quite so far off the rails. So we're up to 99,940 tokens burned for this. Let's see, where are we at here? See if I can expand this. Oh, I think it's actually working. I think right now it's currently in the process of testing the upload. Let's see. Call PHP Web Shell Dice Co. Yeah, boy. So the exploitation agent worked right there. And then it's going to die here because we actually don't have the functionality built in for it to return execution back to the exploitation agent. Which is fine. That's a fine problem to have. It actually went through the entire exploit chain. Boom. Yes. So those 2 weeks worth of code loss were recovered in 5 days. J Money, play it. Dude, I am good, man. I am good. So, quick recap, J Money, and for anybody else who's new, when was that? Less than 2 weeks ago. Sunday on the 5th, the exploitation agent was working. It did, for the first time, its full successful exploitation run. And when it did that, I'm going to go ahead and kill it now because... Oh, it already died. It was stuck in a loop there for a sec. It did the full exploitation run. So it went through, it identified where to do the upload, where it was probably going to land. It's a very, very basic example, but it's exciting to me. It went through and it did an upload, it did an error correction, it found out how to bypass the upload restriction, and then it did a call and verified that it was working. So now what we need to do is go fix the routing, because here's the problem. So this is what this execution looks like. Let me bring this up here. I'm going to bring this guy over here. Just like that, because we don't care about these two guys right now. So here's what happens. Here's basically all the nodes that matter in here. I'll put this one up here. So when this loads up, the exploitation agent is given a task right now because we bootstrapped it and said, hey, go get a PHP web shell on that target, right? Get a web shell. So the exploitation does a quick check. It goes over to the validator here and says, by the way, before I go exploit this target, do I already have an initial access payload that works on this target? It says, no, we don't. We have not exploited this target. We don't have access to it. And it passes back to the exploitation agent. Exploitation agent then looks at it and says, okay, that's fine. Let me go tell the exploit planner what I want it to do. Exploit planner comes in and says, all right, I'm going to plan out the steps we need to do for this. So it comes in as a task. It gets assigned an exploit task nested under that, and then exploit steps nested under that. And the step planner is the one that goes and creates those steps. Then it goes through this kind of processing loop here. So anywhere you see these kind of dashed lines versus say like a solid line here, the dashed lines are conditional jumps. So for example, exploit agent could pass to step planner, or it could pass it to validator. So it just depends on the conditions of the state table. But exploit validator has to always, when it exits this function, pass back to the exploitation agent. Same thing kind of happens over here. After it runs through this loop of checking the steps, making error corrections, getting it working, it should be able to pass back to the exploitation agent. However, this conditional jump is actually just hard-coded to never go to the exploitation agent. It just always goes up to the step processor. So I need to fix it. We actually have to go fix the routing function. Yeah, it's very cool. It's efficient monkey whenever it works. Sometimes what happens is the browser agent, which you don't see in here. So when this special agent node gets called, it can pass execution to a special agent that gets hot loaded at runtime. When that happens, it doesn't show up in this graph because this is a specialized interface provided to us. It's called LangGraph Studio, but I think they're actually renaming it to Langsmith Studio. The guys at LangGraph are getting ready to rename this. Currently, it's called LangGraph Studio. But we don't have the agent's entry points defined in here. There could be a way we could potentially do that, now that I think about it, but I don't want to mess with it right now. The goal is to get the exploitation agent working and stable, and then move on to the post-ex. So currently, we're in Let me collapse this down. We're working on this guy right here. This is nothing, don't worry about that. There's one more primary agent we have to work on, which is post-exploitation. There actually may be another one. I'm going to think about this. No, post-exploitation is fine. So post-exploitation is going to be handling everything post-exploit. Exploit's job is to create what's called an initial access payload. Its sole job is to be able to execute at least one exploit call at a time, repeatedly, right? So like the web shell is a perfect example. We make one HTTP request, we get one code execution. Boom, that's it. And then the PostEx job is to take that and first upgrade it to a C2 connection, and then two, handle all the interactions with that host after it gets that C2 connection. So we're actually going to have to go do a ton of integration building because it's going to be handling everything over with Mythic C2. So push it out so you have it. Dude, it should be pushed. Nothing changed in the code. I just literally loaded up. I'm back to doing nightly pushes up to GitHub. I'm not letting 4 months of code stack up again. I was very fortunate that I had a power outage 2 weeks before the code loss. And if I hadn't, I would have lost months of code as opposed to just 2 weeks. So, like I said, I was able to recover this in like 5 days here, as opposed to losing it in, months. I would have cried. You would have seen a grown man cry on stream. That's what would have happened. Because there was a lot that happened in between there. So now, let's go take a look at this guy right here. So this conditional jump from the step revisor. Right now, it's hard-coded. It looks like it can go to the exploitation agent, but it can't. So we need to go fix that first. Love you long time, Gumby. Yep. Made me so happy. This sparks joy. I think this is saying our Langgraph server is out of date. It's not very out of date. It's fine. All right, so let's go take a look at... Let's take a look at the state table here. So... Notice how we had a call to PHP Web Shell Diceco again? It's because after it did this, it got stuck in this loop right here. It went back up to the processor rather than saying, okay, yeah, we're good, and passing it to the exploitation agent. So we're going to have to go to that routing function and double check it. Actually, we'll probably need to make some updates to the revisor. So let's go take a look at the state table after it finished this Diceco. So we go to... see. Yeah. So let's look at it after it finished exploit step update, before it goes into the revisor. So we can look at the input state table here. So let's collapse this down. Let's see. No, I want task. All right. So here's our exploit task. And then what we have here is, so inside of the output is where the exploit task data is stored. And then that exploit task has these steps. And so in the steps key, that's where we have all the exploit steps right here. Let's see. So how do these look like? Validated, 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 new. Now, why was there a new one here? Test the web shell to confirm successful deployment. Oh, because it hasn't revised it yet. Okay, I'll tell you what. Let's come down to the step processor real quick. Because we want to get it post-revision. Because that would be the state table that we're going to be actually working with in the routing function. So let's come down here. No, for some reason, this did not get updated. Oh, actually, right here. Access the upload web shell in the uploads directory. That's why. Oh, so there was one more step that was supposed to happen here. See that? So when we said access the upload web shell in the directory, what happened here is it said, oh, okay, let me just go call PHP Web Shell Diceco. And that's just a tool call that automatically just, you can pass it a command, RoboPages formats it and sends it. Okay, got it. So it did have one more step happening here. So maybe in the revisor, we need to add something that says, because it could be possible, hey, we got this beforehand. Dang, I shouldn't have killed it so soon. All right, let me think about this. Because I need to know, what was this last step going to do here? In fact, let me show y'all this real quick. So initially there were only 5 steps in here. Now you notice there's 6, 0 through 5. So we had navigate here, upload the PHP web shell through the form. But then before that, there was a rename. So what happened here is this used to be index number 2. And then when the revisor came in and said, our upload is failing, we need to try a different name for the payload, it actually inserted this step and said, hey, go work on this one first. Just run it again. I don't want to run it again. I want to leave it like this. Okay. So there is one thing I need to look at for this. I'm trying to think. Because I'm trying to think of what the state's going to be. Actually, it called it... Damn. I wish I hadn't killed it right there. Damn it. I could just run it again if I wanted to see it. Alright, you know what? Screw it. Run it again. Do it. Actually, hold on. Cancel. I need to do one thing real fast. I need to actually come over to here because we got to go get that sucker off of there. Otherwise, it's going to try and use the web shell it's already got established on there. Let's go here. Uploads. Right, so here's our DiceCo web shell PHTML, and for some reason we've got 2 in here. Let me try something real quick. Let's do CV. Oh, forgot to actually give it the command. Who am I? Right there. Bam. So we're tripped up. Tripped up's data right here. All right. So let me try. What's our present working directory? It should be, yeah, uploads directory. That's fine. And so if we do a ls, oops. Oh, I see web shell. All right, I think we should still be able to RM that. So we're gonna do a RM web shell. Webshell.phtml. All right, so now if we do an ls, we see DiceCo. So then we're gonna remove this one too. And then now if we go back to the uploads directory, we shouldn't see anything, hopefully, in there. Yeah, so now we've basically cleaned up the box, so we're back to our initial starting point. All right, let's see. Exploit. Wait, why did you die at the exploit agent? What happened? You're not supposed to die at the exploit agent. Oh, user run interrupted. Yeah, actually, I killed it. It was supposed to die. All right, run it again. Run it from the top. While this is running, I'm going to run and get some water. I'll be right back. Wait, here, I'll just leave this on for you. Boop. All right, I'm back. All right. Water is short for he's pooping. Yeah, exactly. That was it. And I brought it back with me. You bunch of weirdos. All right, let's see. Actually, erroring out on the exploit step processor is a good thing because that means it went through the entire chain, in theory, and then died when it ran out of tasks because it couldn't route back. Yeah, list index out of range, that's actually a good thing. Because... Wait. No, that is not a good thing. What the hell? What is this? What the crap is this? Okay. Step planner, you're killing me. You're killing me. Hold on. Let me look at something real quick. Where did the code loss happen? So the code loss happened on the 5th. All right. Let me see if I have anything from back here before the 5th. Let me see. Let me come back. Because I want to look at something. Last 7 days? No. Give me the last 14 days. In fact, even the runs from the 5th would be fine. Okay. This was the last one I did on the 5th. Why the heck did it take so long? I think this one, the browser agent went JSON born on us. Or maybe we just had some, like, I don't know, some lag or something. Yeah, it went kind of nuts. Let me back up from this one. I tell you what, let me go to the one before that, this one here. Let me see where this one errored out. Okay, no, that one didn't work. Where was the one I tagged? Hold on. I think I remember which one it was. This one. I'm pretty sure it was this one right here. Hey, Bobby, what's up, dude? Here we go. This one looks a little bit sus, but actually looks like it worked. So it called Diceco. Yep. Boom. And called it twice. So let's take a look at this part right here. So what did our state table look like here? Because if this is the correct one, then what we can do is we actually have a log of what the system prompt was. And I can go double check the revisor prompt and see if I had made changes to it and I need to go port those back over. Let's see. So here's all of our steps. This one, for some reason, didn't validate. Oh, it's because of just where I'm looking at it. Never mind. Don't worry about that. The revisor should be fine. Let's see. Yeah, so this one worked because we got UID 33, which meant we're running as tripdubs data. Perfect. All right. So now, let me come back up to the top. How much did this run cost? 417,000 tokens. That was expensive. Damn. Hold on. How much was this one I just ran? So for some reason, that one was 4 times the entire Stinger run that we just did. That actually completed the whole thing. That's weird. Anyway, let me come down to the revisor. Let's see, step processor, revisor, here we go. So if we look at the actual call that we sent to the language model, this is what we had. Okay, I'm pretty sure that's what we already have over in the code. Let's see, let's pull this over and look at the prompts. Yeah, that looks to be correct. Okay. All right, so we still need to do, so the prompts in this are really basic. I haven't done a ton of like, finessing of the prompts. I just go add to them as issues get encountered. So we say, okay, we've noticed a behavior problem. Let's correct the behavior problem in the system prompt. So the division of everything has been, here's our system prompt, and then our user template, our user prompt basically reflects what we're told in the system prompt. So this is all instructions. The user prompt is all data, basically. Let's see. Yeah, so consider the nature of the blockage if a correction step is needed. All right, so actually, I take it back. This should be in the planner. I stand corrected. Because the planner prompt, this is the one we wanted to look at. So where's our exploit planner prompt? Let's see. Okay, so for example, given the task upload PHP, let's see. Artifacts are available like PHP web shells. Always prefer gathering artifacts over creating. Okay, so I think we've pretty much got the exact same thing in here. Let's do another one in here. Let's see. Think step by step. Condense the number of steps to the, I don't know, what do we say, minimum? Let's see, minimum required. Yeah, we're gonna try that. So what I'm hoping here is, for some reason, a lot of these language models, when you include this step by step, it starts going through a loop where it actually does kind of provide more accurate information. So we're gonna tell it, hey, think step by step to condense this. In fact, actually, I'm gonna split this up. Let's see. I'm going to move this up here. Condense the number of steps to the minimum required. And I'm going to put it actually up here. So here's what we said. You're an expert cybersecurity agent specializing in planning exploits for initial access to a target. Your primary job is to analyze the task and target data to plan the steps necessary to complete the exploit task. Let's see. I'm going to actually put it right here. Your primary job is to think step by step to analyze. Yeah, we can say that. Your primary job is to think step by step to analyze the task and target data to plan the necessary steps to complete the exploit. Yeah, okay. Because what happened here, we come up to this latest run right here. Actually, let's compare it to this one here, right? And if we come down to the exploit planner, let's see, where's the planner? Planner. Where are you? Here we go. Here's where we entered the exploit agent. Okay, here's our planner. It came back with very basic instructions, like it should have. Obtain a web shell, navigate to the panel, upload the web shell, access the upload URL of the uploads directory, test the web shell to confirm successful deployment. Boom, just like that. So real simple. Yep, okay, awesome. Instead, if we compare that to the one we just had up here, let's see. Exploit, where's the exploit step planner? Processor, planner. There it is. If we look at this one, it just went like off the rails. Obtain a web shell from artifacts, analyze the upload form for potential restrictions. You don't need to do that. It should have, if the upload fails, then it will go through and analyze it. Modify the web shell file to bypass extension filtering. You shouldn't be handling that. The reviser's job is to handle that. Upload a modified PHP. It's like, no, all these are bad agent. So now, cool thing is, that should all hot load in. So let's go try running it now with a little bit extra information when it's doing the step-by-step. Where is that? There we go. All right, let's go run a new exploit run. Execute. Let me check something real quick. That wasn't it. Bobby, I looked at that Harvester game that you recommended. Dude, that thing came out in 1996. I was looking at the screenshots for it. That game looked like it was made for like the Sega CD. There's like all these like what was considered high res at the time, like cutscenes that were actually filmed and then converted over to like moving bitmaps. It was kind of funny. So I don't know if I'm going to play that one. Is it really that much of a diamond? All right, let's see. So if it's on the special agent node, that means... let me refresh this because it's not loading the latest run that should be executing right now. There we go. Let's see where we're at. Oh, what are you doing? What the hell? Is this timing out? What the heck happened here? Navigate to panel. It's because we didn't have any information here. See that? All right, let me cancel this run. So our new condensed steps are good. However, now the planner needs additional information because look at this. It was given information here, but wasn't given information about what the URL is. So it literally tried to go to like /panel instead of IP address /panel. Oh, that's funny. They weren't high res at the time, but we didn't have video, so before that was still neat. I know, right? I might go check it out. It might be fun to play. How many hours is it to complete that game, Bobby? Let's see. All right, so the problem is we're missing some context around the target here. So one thing I don't want to do is go give this thing like the entire target context for this. Let's go look at something real quick, because here's the host information, right? This is our target host, 10.201.6.122, and we've got a lot of information from this guy here. All sorts of information. I don't want to go flood the message context with this here. So instead, let me go double check something in our exploit. Okay, so our exploit task does have a target IP. Because everything's kind of working on IP addresses. So we could go pull out the target IP address and let it use that. I think the better step is for the planner to actually let's go throw another instruction in there for the planner. Actually, one more thing before we do that, let's go see how did the planner respond with the new instructions. So we told it to think step by step to analyze this. What did it come back with? Let's see. I'll analyze the task to upload a PHP web shell to panel directory that bypasses extension filters. You were told to bypass nothing. Nothing. Let's see. So let me create a step-by-step plan for this exploit. Okay. That did not work. It did not work. Okay, your primary job is to think critically. and to analyze the task and target data. Let's change this a little bit. Well, analyzing the task and target data to plan the steps necessary to complete the exploit task. Let's see. Additional context may be provided for previously failed exploit attempts. All right. Condense the number of steps to the minimum requirements. Let's see. URLs and file paths should be, let's say, fully qualified. We'll say that. Because what happened here is it said go to panel. All right, panel on what? That was the problem. I can't recommend that game enough. The game is completely insane in all the right ways for the game. On the opposite end of the spectrum, I would recommend something like Evil Within for the action horror or Visage for truly horrifying. I actually had thought about playing Evil Within. It looked really interesting. I'll go check. I will give Harvester a fair shake though, but that was like my first impression. Let's see. Navigate to the web application URL page. Let's give it a little bit more example here at http://x.x.x.x / let's see, upload page. I'm gonna put it like this to try and give it the idea that, hey, these are placeholders. Let's see, upload the PHP web shell, perform a request to test the web shell. Yeah. Mateo, hey, what's up, man? All right. So telling it to think step by step completely screwed up the instructions. Although we had screwed up instructions before that. I'm going to actually take out this part. It has no security features. Let's see. Provide the minimal list of steps to accomplish the task. Condense the number of steps to the minimum required. Oh, so we actually already had an instruction in there. All right, let me take this one out because we're duplicating this. Provide a condensed set of the minimal. Actually, yeah. We'll say provide list. Provide a condensed list of the minimal steps to accomplish the task. Assume the target has no security features. Artifacts are available for code samples. Always prefer gathering artifacts over creating artifacts. Yeah. I'm learning Quilt to make Minecraft mods at the moment. Java is hell. Dude, I hate Java. I needed to make a I'm working with a Python library called Manum. And if you ever seen 3 Blue, 1 Brown, it's the library he created to do his mathematic visuals in Python. And it's really, really cool. But I prefer to work in PyCharm and not in VS Code. So there's an extension to preview the animations as you build them out in code in VS Code. And I don't want to do Java, nor do I really understand the structure of what the plugins do on PyCharm, nor do I really care. So I threw that task over to Claude and went through something like, I don't know, 30 revisions, but it actually did make a workable plugin where I can go preview the animations after I make them. Oh, you used Manum for math assignments? Nice. I really like it. I'm actually testing it out for doing like attack path demonstrations. So have a node appear, have it show like, okay, this is how we're moving to this node, have a node appear, and those nodes would be like computers in a network, right? So that's what I'm kind of testing it with. So I'm going to try to make it like a little overlay library. Makes it real simple to say, here's all the nodes, and we're going to mathematically assign them to a position, and then we'll have the camera zoom in and kind of follow the attack path and maybe have some like explanation show up of what it's doing. I had to do a presentation and got extra style points. Nice. Nice. I think it's sick. I didn't know he had open sourced that library. I just recently learned how he made those animations. They're so freaking cool. Let's see. Is there anything else I could put in here? I'm going to change this slightly. I don't know if it's actually going to make a difference, but... Upload... Upload page at. I put as instead of at. Let's see. Upload the PHP web shell. Perform a web request to test the web shell. Boom. I'm going to put another example in here. Let's see. I'm going to put in like, let's put in web shell path. Web shell dot PHP. There we go. Oh, just like that. I think that'll be good. Quote with Java is just scuffed sometimes. Like the template GitHub repo wants to use quilt item settings, but doesn't set the dependencies so it can be implemented. That's weird, man. Although I'll probably will eventually learn those things because my older son is obsessed with Minecraft. My younger son probably will be at 1.2. And so I think that'll be a fun way to introduce him to coding is to go do Minecraft mods. Let's see. Alright, I think that might work. So we changed this prompt a little bit. Don't include any security bypass techniques. Yes. Actually, let me clean this up a little bit. Security bypass steps. Yeah. Let's see. Double file extensions, obfuscating code. Yeah. There we go. I'm going to try it like that for now. It's way too complicated to do Pygame or something. If you really want to let them do Minecraft mods, then inform yourself months in advance. Oh, I plan to, man. And I don't even actually really care for Minecraft, but, you know, if your kids like it, then you're going to do it. Let me see here. Did that all hot load in? I think so. All right, let's go try another run real quick. Except, I need to double check. Oh yeah, we still got an hour left on the try hackathons. Perfect. Perfect. Let's run this sucker. New thread. Execute. Let me go see what it came back with for steps real quick. Because if the steps are off the wall, I'm just going to kill it. There we go. Now we're looking better. Get a PHP web shell artifact. Navigate to the upload form. Upload the PHP web shell through the form. Access the uploaded web shell at... Perfect. I think it probably would be a good idea over in the browser agent to extract the target. It really shouldn't be target IP. It really should be like just target. Let me look at something in one of the data structures here. Yeah, so we do have target IP in the exploit task. Really, it should just be target here. I'll think about that. Because it really could be like target host name, but whatever. If you want to do Minecraft mods, then start with either Quilt, Fabric, or NeoForge. There's no point learning Forge for newer versions and follow the standard wiki. Okay. I mean, if I'm going to be running it, I don't know which version it's going to be yet. There's so much about Minecraft and modding that I have to learn. The coolest mod, or not really mod, but the coolest thing I think I've ever seen in Minecraft is there were two things. One, I think they made like a quantum simulator in Minecraft where as you moved, like the environment changed, like if you were like observing it at a quantum level. And there was another one where a guy made like I want to say he made a processor. He made like a CPU in there with like, I think 8K memory or something ridiculous. It was pretty cool. Newer versions as in from 5 years ago. That's new. That's funny. That's considered the newer version. All right, let's see. So we did a navigate, we did a click, file upload, click, console messages. Why are we checking console messages? Oh, so after the upload failed, it checked the console messages. And then how did we summarize this? Let's see. Okay, cool. So then we should get a rename file. Yep. Click, upload, click. So now what it needs to do is it needs to go verify. Let me see actually what's the task actually called. Access the uploaded web shell at this. Okay. All right. That was a little too literal. Because it shouldn't have been access, it needs to test it. All right, let me see here. Let's go update the prompt. Let's see. Perform a let's see, perform a test of the web shell. Yeah, let's change this a little bit. So we are kind of cheating a little bit because in the system prompt, I'm putting an example for this particular exploit. But the theory is this is called a one-shot prompt where we've given it one solid example of like what is acceptable. And so we might add a two-shot prompt where like, hey, if we find one that's completely different, we could put it in here. Another idea I had is eventually I did want it to have a retrieval augmented generation pipeline where it could actually go and request information on certain exploits and like how to perform them. So for example, this would no longer be in here. We, instead of for the step planner, could go make a call that says, okay, hey, I need resources on how to do this particular style of exploit. And then we could have these steps over there. Test the web shell at to confirm command execution. There we go. I'm going to rename this a little bit here. So it actually did work, but it didn't quite work because once this was done here, I think we're going to need one more check. Let me look at the graph real quick. So here's our exploit step revisor. I think actually we need to have one more node in here So once this is done, I think what we should do is potentially have another node here that exploit step revisor could pass to, and we're going to call this the exploit, maybe like the exploit task validator. And its job would be, hey, we want to confirm that everything you've done actually did get us an initial access payload before we pass it back up to the exploitation agent. Let's see. Pygame is very versatile. I recently used it to make a very basic simulation of walking. Oh, cool, man. Like, what do you mean for like walking as a Minecraft mod? Because I'm fascinated by the entire modding community, and eventually I'd like for my son to be able to make some Minecraft mods and make me money as opposed to spending all my money on Minecraft mods. I think he'd really enjoy that, actually. He's very creative. Yeah, I think what we're going to have to do here is this conditional jump shouldn't go to exploit agent. We're going to add another function right here. We're going to call it the exploit task validator. Or heck, we could potentially just go pass it up to the exploit validator. Yeah, let's go take a look at the exploit validator, because I think we actually could make use of that. Let's bring this back over. Where's our exploitation agent? There you are. You're so cute. Watch some of the Dr. 4T videos? Okay. Would you believe it? That's actually one of the ways I've encouraged Agent Zero to get good at his reading. Like, because he's only 6. And one of the reasons why I've done that is because he saw this YouTube channel called Mikey and JJ and was watching them do like basically like hacker mode mods or something like that. He's like, Daddy, I want to hack like on the console. That's what, I don't know, Mikey or JJ, whichever one of them does it. That's what they were doing. And I was like, dude, you gotta learn how to read. You gotta be able to read. You gotta know math and how you're gonna do this. So it's actually been really encouraging for him to do that. All right, so here's the validator. What do we have for the validator function here? Let's see. That's how I learned English? Nice. I need to go actually practice my Spanish because my wife speaks Spanish because her mother's from Mexico, and I don't speak hardly any. I understand very basics. My vocabulary is absolute trash, but my kids are learning it right now. And I was like, they're going to talk trash about me behind my back if I don't learn this. So I really do need to get on the ball for that. Okay, so for the validator, we go get. We check the current target task IP. We check the state. We go ahead and validate that we did the pre-flight check. Let's see. So if the current task has no initial access payload, then boom. Okay. So it's looking for the initial access payload here. So we need the. Yeah, we are going to need one more node in here because what's happening is this is validating the task, right? Which means we need to validate the exploit task. So if we come down here, yeah, maybe I could do that on the router, even. Hey, Mateo, thanks for coming online, man. Let me take a look here what we got. Same thing with me in French, but not wife, but mom. What I find funny is that actually my dad grew up in Louisiana, and so I had a lot of French background from there. But then also my grandmother on the other side was from Canada, so I got French from that side too. So I thought that was actually pretty funny. Let's see. Okay, so here's all of our steps. Did they all validate? Okay, so they did all validate in here. So we need to probably do one more check in here that when this validates in the step processor, or when the revisor validates it, we should probably do one more check to see are they all validated. Actually, we could do that in the routing function. If they're all validated, then we're going to pass it up to the exploit task validator. Because we have the exploit validator here. Yeah, I think that's the best way to approach this. Yeah, we are going to need, I think, one more node up here. I got a pretty one-sided family, except for a Chinese guy and a mom who lived in France for like 10 years and then moved back to Germany. You got that global family going on. My family's pretty much all from Louisiana and Texas, except for my grandmother. That she was the weird, odd import. I don't know how my grandfather, who was born and raised and lived and died in deep East Texas woodland, how he got up to Canada to find my grandmother. I have zero idea. A raid? Hey, J Beers, what's up, dude? What's shaking? What's this collaborate thing you sent me? I tried to check it out, but it's like what's funny is like it's like, hey, go preview the stream, and like it's ads. That's all right. I'm just gonna accept it. We'll see what happens. Let me see what happens here. I have no idea. Think it's on? I don't know what this thing does.
Caution. A virus
What does it matter
has been
now?
detected.
Spears 11 virus detected in the network.
Hey, J-Beers and Raiders. Welcome in, y'all. What were you working on, dude? What was going on? I tried to look, but it didn't happen. Get you my shout out real quick. J-Beers is super fun guy. Give it in there. Oh, also I forgot. Cookie Monsters. Just slow down the virus. What's good, bro? Dude, having a good time, man. This CTF AI agent is actually working pretty good, but now that it's actually working, we actually have to finish the workflow. Because before, everything was just focused on getting it down here to do the exploit steps. I haven't planned for the exiting of that loop. You're studying for the OSCP, but gonna start doing bug bounties again. Nice, man. Sick, because you found some really sick ones in the past. I don't remember them exactly. I just remember J-Beers, bug bounties, sick. I have those 3 words chained in my brain. Oh, you're gonna do them all on Twitch? Nice. Nice. Was it you that found the one, I think it was in T-Mobile? Was that it, in T-Mobile's bug bounty? Yeah, okay, I thought that was you. Yeah, I remember that one. That was cool. That was sick. I caught that one live. That's so awesome. So guys, if you like this kind of information, by the way, J-Beers, are you not on InfoSec streams? I doubt it caught the stream ending that fast, because usually the site lags by like a minute or 2. But yeah, go check out J-Beers. Shy Hat's also on, I see that. Did you see the thing that Twitch is doing where if you have viewers lurking, your viewer count will fall off and they don't say anything in chat for a certain amount of time? I heard about that, Gumby, but I mean, for me, it doesn't really affect me because I don't stream for money. Right, I do get paid from Twitch. It's not a lot. I think last time I figured it out, it comes out to like $2.50 an hour. But it doesn't really bug me that much. It might have been deleted because there was no streams for 4 years. No, because you did the T-Mobile one more recently than that. 4 years, that's an exaggeration, sir. That's an exaggeration. Mateo, if you want to learn more though, go throw JBeers a follow because he'll show it and he gets down nitty gritty and explains it. I tell people, even if you're not planning on going into security, understanding security is a good thing. Just like if you're not planning on going into fights all the time, knowing martial arts is still a good thing to know, right? Maybe just knowing some basic defense and how to protect yourselves or fight off somebody, right? It's along those same veins in my mind. Yeah, so JBeers, this is pretty fun. It's doing a very basic web shell exploit, like just upload, do a file extension bypass, and then re-upload. It's super, super basic, but it is working. So now we're trying to figure out how do I get out of this execution loop here? And I think what I need to do is go add one more little node function right here. Just a happy little function right there. So let's go do that. I'm going to add it post revisor. So let me come down to the revisor real quick. Let's see. So here's our exploit step revisor. Actually, we're going to add it post router here because we're going to change this. Let's see. To do change to. We need to change that to route to exploit task validator. There we go. Let me change that real quick. And then we're going to make the exploit task validator. So what we're going to do is we're going to define, let's see, exploit task validator. And that's going to take in state, stinger state, just like that. Boop. I'd like to know more about cybersecurity since I want to do software dev as a day one job, or as a job one day. Dude, one of the things that's also really good, and good reason to know that is because a lot of companies, they really push you to do what's called secure coding practices. So secure best practices, like, hey, if you're doing a, for example, if you're doing certain kinds of like SQL calls, there's ways you want to structure them to prevent or block exploitation of injecting SQL queries inside of like your other query, right? So that's called SQL injection. So you'd want to know how to do that, or just how to do things in a memory safe way. So that way you're not maybe misallocating buffers or doing whatever. So yeah, knowing security is a really important thing. Pretty much any vertical you can think of in technology, there is a parallel vertical right next to it, glued hip to hip, that is security, or should be there, really. So think about it. You got front-end devs, there's security around front ends. You have back-end development, there's security around back-end development. You have databases, there's security around databases. You've got, and just don't think just because you have shipped it off to where it's like some third-party hosted SaaS system that it's still not important. It absolutely is. Heck, you think about like you've got cars, right? A lot of cars now have interconnected systems. Right there. I had a buddy who used to work doing security assessments for an automotive maker, and he was telling me about it. He's like, bro, everything that's old is new. They knew nothing about security. Everything, all the old tricks are back. They're back with a vengeance. All right. So in this validator, what we want to do is, let's kind of metacode this way. Let's see. Actually, there's one thing we want to do here. In the router, we want to check this real quick. Because right now it's just if true, go to the step processor. So there's other things that we want to do. So one thing we want to do is we want to iterate over all of the steps and see if there's any steps that are not validated. Oh no, that's not going to work. Because a step is allowed to fail and then could be, basically a new step could be done in its place. So how do we want to do this? We need some kind of condition in the state table that exists to tell it, hey, by the way, router, I think we're good. We're going to move over to here. Actually, that gives me an idea. Let's see. I'm going to actually test web shell 2. Confirm command execution. Because what we're going to do is we're going to put one more step in here. We're going to say, let's see. The final step must always be a test of the test to verify command execution. So, just like that. There we go. So we're going to give it one more informational step, and then we're going to give it this right here. Boom. I know some about memory stuff since I deal with C a lot, but never know too much. Dude, there's so much in there. Crap, what was it called? I can think about it. It's the one I went through when I was doing the OSCP, and we were doing very basic buffer overflows. He's got an entire course laid out on not memory safety, but like on very basic exploits. Is it byte loader? Bytelander, I think that's the name. Bytelander exploit 2. No, that's not it. It's not Byte Bleeder. Crap, what was his name? Byte something exploit tutorials guy. What's his name? Nope. They got Roblox. Oh god, I hate that I cannot remember his name because he always has he has amazing stuff. Damn it, this is gonna bug me. He doesn't teach you any classes online. They are all in person and they're all very expensive because he is very good at what he does. Oh crap. What the heck was his name? Let's see. I can even remember the code. I want to say he used WinDBG. Let's see. Let me see if they have any references to it. I don't think so. No. Not Trustwave. God, this is such an old site, too. Coreland. There it is. Yes. Coreland. Damn, I was way off. Bytelander. There it is. Let's see. Coreland exploit tutorials. Coreland.be. There we go. So here we go. Mateo, check those out. They're really good. And he's got them in here. Let's see. And like I said, these are from like 2016, right? So stuff that's way old. I think the stuff I was going through was even way older than this. Hey, 57, what's up, man? I'm doing really good, dude. Having fun. We're buffing up the exploitation agent. It's almost done. Let's see. That's 2013. Nope. Older than that, because I was doing this stuff in 2010. Let's see if I can find it. He had a whole bunch in here. Reversing 101. Let's see. 2011, 2010. Yeah, it might have been around this part here. Solar Winds Orion. God, I forgot about that one. It's a classic. Let's see. But yeah, go check through here because he's got a ton of these, Mateo, and it's all really good stuff. It's older stuff, right? There's been new developments in there. There's a long history of understanding like how certain exploits work, and exploit developers have found ways to work around that. So like, for example, they added stuff like stat canaries. There's ways around that. They added like non-executable memory, but there's ROP gadgets that I believe you can use to get around that. I'm not an exploit dev. I only play one on TV. Anthropic's gonna have real competition now? No, man. Not with this. This is a little toy project, but it's fun because I'm making it. But what we're looking at now is it's actually completing the exploit steps. So what we need to do is come back to the revisor and then come back to this section here. And we're going to come and we're going to make one more node to validate the entire exploit task. If the exploit task validates, then we're going to come up to the validator and then we'll validate the parent task. So this is nested, like we have a task, we have an exploit task, and then we have steps under that exploit task in there. So what we need to do now is we're going to go add exploit task validator in here. Let's see. So our exploit task validator, what we want to do is we need something in the routing function. So let's put a to do in here. So to do, figure out logic to pass execution to, let's see, exploit task validator. So rather than going to exploit agent, this is going to go to exploit task validator right here, but this is not a reachable code. That's why it's complaining about this. So what could the logic be when it needs to go to the task validator from this? So one of the things we could do is if that last task needs to be done, then we could move on from there. So what I'm trying to do is I'm trying to keep the language model from going off the rails, right? And in fact, that's even one of the OWASP LLM top 10s is excessive agency, where you give it too much freedom and it just goes wild. So we're trying to keep it very focused and very narrow in what each of these calls is doing, and then we're building kind of the mind map and the context behind it to control the flow of the data. So the question is, if we just validate the very last message, so we're assuming that our planner is going to do a proper job and make the very last task to be testing the execution is working, because that should confirm that the initial access payload is actually functional. Then, as working on that assumption, we can say, okay, as long as the last step is completed, is validated, then we could route to the exploit task validator to actually have it go through and analyze all the steps taken and all the output, and then have it say, okay, yes, everything looks good. Now we're going to build the initial access payload. Oh, which that is going to be... How do we define the initial access payload? Hang on, let me go look in the states real quick. No, go back. I need you not here. I need you down here. Right here. Boop. Let me throw that right there. Let me bring this over. So we define that as part of the host. So where's our host here? Initial access exploit. Let's see. Payload for single command execution on the target. So we defined it kind of broadly. Payload could be even just making a tool call. And it doesn't need to necessarily be exact. Oh, it kind of does. So I'm thinking there's one other thing we could potentially do, because right now we've got a tool that gets us the artifact. we have a tool that then allows us to call the artifact. So either we need to structure something in here that says, like, perform a tool call to do this. But the reason why I'm hesitant to do that is because then anytime something wants to use that, it has to have access to that tool. It's not such a big deal. Let me look at something real fast. Let's go take a look at what does our or what does our overall language model call look like when we're sending this huge chunk. So if we look at the exploit step processor, this is all the stuff we're sending right now. And this is an area for optimization, right? We can cut so much of this down. There's no reason for the exploitation agent to be doing nmap scans, right? We should have already done all of that in recon and enumeration. Wait, we actually had one. What did I do here? Hey, thanks, past me. Get PHP Web Shell Diceco initial access exploit. Command to run on the system hosting the web shell. Okay, that doesn't sound right. Let me go pull up the PHP for that fast. Or not the PHP, the YAML file. Let's go get the YAML file. Hey, Scam, what's up, man? Sorry, I just saw your message here. What LLM model are you using? Oh, we're just using Claude 3.7 Sonnet right now. Hold on, I can tell you. Yeah, we're using Claude 3.7 Sonnet right now. Nothing spectacular. Eventually, I'm going to add an option for like Ollama and OpenAI to this. That's going to come way later in the development cycle. But yeah, Claude 3.7, that's what I started with. I didn't want to switch to anything until then. Yeah, so it's a lot of fun, but because here's kind of the current state of the project here. Oh, that's weird. Let me bring that down here. So as it sits right now, we're working on this agent right here. This is the supervisor agent all the way around. And there's another agent and then the actual supervisor itself that we need to finish coding. This one we haven't started yet. This one's just bootstrapped. It doesn't make any language model calls at all. It just divvies out tasks. So eventually we're going to have to work backwards from here. Of course we got ads. Stupid ads. They always come at the worst time. I got you, bro. That's all right. Papa Bezos has to get his bucks. I'm so excited about this, though. The exploitation agent's finally starting to kind of work. So much fun. When did I start this project? When did I do the first code commit? The initial commit was on January 21st. So we're working on this for 10 months now. All right, so Scam, what I was saying is there's still a lot of work to do before I start updating a few things, right? So we started this project January 21st. Really awesome day in history, by the way. And right now we're working on this exploitation agent. So everything you see here, this is actually the supervisor agent here. So it's supposed to handle passing execution to the individual agents to do their job. So we're currently working on the exploitation agent. There's one more yet to be defined over here, but that's going to be for post-exploitation. Handling everything that the exploitation agent hands off for talking to the computer back and forth consistently. So we're going to have to do a lot of work there. Then, once that's done, we have one more thing we have to do, which is the stinger agent. So right now, we actually give it a list of everything it needs to do, and it, like breadcrumbs, and it walks through that list. Eventually, what we're going to do is we're just going to tell it, here's an IP address, go hack it. And it's going to go through it in usual CTF style and do recon and enumeration, and then walk down the chain itself. So as these things finish, they'll pass their execution back up to Stinger. Stinger will look at what they did and decide the next course of action. And with the goal in mind of we're going to try and exploit this system to get a persistent payload and then root it. This Windows 11 upgrade really effed me over. I have to reinstall all my VMs. Ugh. Dude, I'm hard set. I'm really hard set about like not using Win 11 on my primary computer. There's a lot of different variables I'm considering right now, but this computer will never run Windows 11. So it's a bot for automating bug bounty hunting because it works like it would be free money, or is it purely CTFs? Pretty much just purely CTFs. I don't ever intend on using this on like a live production system. I'm a penetration tester by day, and I have a lot of fun doing it. I don't want to automate a lot of that stuff away. There is one little caveat to that though, and that is if we come into the exploitation agent, exploit right there, boop. Where did all these get? Hold on, let me refresh this page because all the graphs got drawn funky. Of course, now you're gonna die on me and just not load. Hackintosh it. I've thought about it. I'm more inclined to go with something like Omarchi because I'm hearing really good things about it. And now, this is of course just dying on me. Reload again. Oh, what's going on? Damn it, I reloaded it and now I can't see what's happening. You're killing me, Smalls. Hang on one sec. Let me see here. Let me see if I can access the URL directly. Did the server die? Hang on. Oh, yeah, it's failing because of this right here. It's trying to hot load in code that I haven't finished yet, so it's just nixing out of there. There we go. All right, so bring this over here, bring this over here. So what we've got here is, you see this node, the special agents node. So one thing I've done is we added a runtime loader that over here in our project, we have a special agents folder. Let's see, where is it? Special agents. So in the special agents folder, you can actually go through and define your own agent, let it come in here and get loaded at runtime, and execution can get passed to those agents to do different things. So one of the things I'm planning on doing is, as I learn new things, or maybe I get some tasks that I just don't want to do manually, I go code them up as a special agent, and I could run those special agents independently. They don't actually have to be run directly by HackBot. You could, in fact, code it up to where it could run standalone. So eventually, I don't think I'll do that with the browser agent, but other agents in the future, I probably will. Hey, Wrench, what's up, man? And Pale Horse, how are you guys doing? Now, I'll be honest with you, I stole the special agent loader idea from, what was that called? Comfy UI. And I pretty much duplicated a lot of the code for the special agent loader logic from Nemesis. Man, Wrench, I'm doing really good, man. We're actually getting to program stuff outside of the execution loop right now. So we have our exploit validator here, but we're going to have an exploit revisor here that right now, this jump is fake. It's just a jump in form only. So we're going to go through and we're going to fix this router here to actually go to a new node that we're going to define. And this is going to be the exploit task validator. So to remind everyone, because the state table is very dense, we have a task. And the task is basically just get code execution, right? And then we have an exploit task. They're distinct things. There is a task and then there's an exploit task. The exploit task actually has all the steps contained under it to complete the exploit. So when the exploit task finishes, we should be able to, we want to validate that that exploit task actually did create work and we got an initial access payload. Once that's done, then we'll actually pass it up to the exploit validator to verify that the initial access payload is present in the state table, and then back over to the exploitation agent. That should tell it, okay, we're done. We got this part done. Pass execution back up to, actually go to the handoff node right here. And that would send it back up to Stinger. If it's open source, it's our code. Yes, comrade, this is our code. Yes, it's very good code. It's great code. Excellent code. You could run it in the background doing bug bounties while you do other stuff. I could, but honestly, I don't. I'll be straight with you. I don't really care for bug bounties personally, and my reason is a little bit different than most people. It's because I work as a penetration tester, and I've done that for 7 years. And I was doing that about the time bug bounties really started blowing up, right? So I did go mess with them and dabble with them, but there's two things I didn't like about them. One, they are almost 99% web-based, and I don't really care for web testing. Can I do it? Yes. Do I enjoy it? Not so much. And two, it felt like I was working so much. Like I was working my day job for my salary, and then I was working at nights potentially for tips. And some of the tips could be pretty big, but those tend to be kind of the exception, not the rule. So I don't really care for bug bounties. I also actually don't really care for CTFs. However, I do care for making things interesting to go play the CTFs for me. Hence where we're at with HackBot. I've done bug bounties and they're pretty hard. So if a company's not good, they'll pay nothing sometimes. Yeah, I know, right? So I had a buddy that found a pretty significant exploit in Microsoft, and they tried to tell him that it was not much of an issue. And then later he had to go fight with them, and it got revised, and then they actually did pay him a pretty decent bounty on it. It's really more the exception that they immediately take it and triage it and realize the true impact of it, or don't try to minimize it and then pay out the bounty. Most of the time it's like, no, you're going to have to fight and advocate for your exploit or whatever you found. So I left bug bounties and started working in a SOC last year. And don't get me wrong, there are some people that do amazingly well in bug bounties, and they have their own secret sauce automation running in the background, and they're very, very smart individuals. But again, they're kind of the exception. All right, let me see here. So, check or get the IEP. Oh, that's what I was going to do. I was actually coming over here to Robo Pages to go check our PHP stuff. So this is our call PHP web shell Diceco that sends a command to our web shell. And then we had one more down here, which is get PHP web shell Diceco initial access payload. Okay, so what did I do for this? Did I actually finish this sucker out? Let me close some of this stuff so I can see the code. That's pretty understandable, but isn't the whole thing, if you don't want to do it, then you let the bot do it, which means that you don't have anything but the bug bounty stuff, which is the reason why you didn't want to do it. Kind of, yes, but also I will be legally responsible if the system goes out of bounds, right? Because bug bounties do have a defined scope, and even though I could put as many guardrails around this as I wanted to, language models at the end of the day are non-deterministic. They're probabilistic. So they always have the chance of going out of scope. So there's so many guardrails that I'd have to put in or try to put in to do that. It would just be an absolute beatdown trying to get that to work. So, oh yeah, don't get me wrong. I love the idea of basically passive income from a hacking bot. But the reality of it is, I'd rather just keep working on my research and do really good at my job, which has taken very good care of me and my family the last year I've been here, because we've had some pretty bad hardships. And I'd rather just stick to that. You 100% have to stay in scope or you go to jail. Straight to jail. You mistap a comma, straight to jail. You exploited the wrong system, believe it or not, straight to jail. Yeah, it's just like dealing with your insurance companies, yeah, right? So, I'd say probably actually, Scam, one of the best things to do with bug bounties is it gives you a chance to go practice web exploitation in a live system and in a legal way to do it. So it has a great learning capacity to it, and there are some really interesting exploits that people find and they can go do on there. But it's just like anything else. It is not all sunshines, rainbows, and kitten farts. There's a lot of headaches that go with it as well. Oh, I think I actually did this correctly. Let me see. So we call the web shell here, just like that. And then here we echo the web shell. Oh, excellent. Excellent. Let me take out examples here. And we actually don't even need anything for this. Actually, no, I take it back. I do want this. However, the command, I need to fix this up. So what this is doing is this was basically a duplicate of this one up here to call the PHP web shell. So this is a tool to execute to call it. This one is a tool to get the web shell initial access payload. I'm going to call this. I'm going to change this a little bit. So I do need to rework this a bit here. You accidentally go out of scope and hack a Russian website? Straight to jail. Oh, never mind. That was just a CIA job. Dude, there's been times, though, as a penetration tester, I had a client that had by far the largest scope I've ever seen. A large external might be, I don't know, maybe 50 to 100 external IP addresses. IP addresses routable to the internet. That's considered like a pretty large external. Maybe even as much as like 500. This client had hundreds of thousands, easily north of 200,000. I don't remember the exact number. It was huge. You know, easily the biggest external environment I've ever tested. And they were so massive, they couldn't keep track of what they owned and what they didn't. And we go and we found a really cool exploit and we pulled it off and we call them up. It's like, hey, you've got a critical exploit. We've got confirmation. We need to hop on a call and look at this. And the very first thing they said is, yeah, we don't own that. What? What do you mean you don't own the system that I just hacked into and dumped all the credentials out of? You better say psych right now. Oh, that sucked. So, yeah, needless to say, we just didn't. I actually tried to reach out to the company that really did own it. They never replied back to my emails. I tried for like 2 months. I'm like, hey guys, you've got a really serious exploit here. You should go fix this. Crickets. I'm like, all right, I tried. Burn all the evidence. Ha, good luck, I'm behind 7 proxies. 7? Those are rookie numbers, Bobby. You got to get those numbers up. All right, I want to change this because we actually don't want this here. Let's get rid of this. And we don't need the URL either. So we're going to take this out. We don't even need this container information here. We can take that out, I believe. I'm going to try this, actually. I'm not sure if we need those to just be placeholders and empty or what. But what we're going to do is we're going to change this. So this is going to be our... No, go back. Undo. Target URL, and this is going to be our OS command. And we're going to put... I think I could put this in here. Let's see. Target URL is pretty explanatory. I'm going to put in here... let's see. Operating system... Just like that. Boom. SOC 17 standard, I forgot. That's right. Oh. Speaking of weird stuff that's like out of proportion, so my wife and I were watching... What were we watching? We were watching Eureka. And so we're like on season 6 of 7, I think. And in there's a... Ah, crap. Didn't like that. Missing parameters. You suck. And in there, they create a faster than light drive, right? And they're afraid that they're gonna like have this spaceship come and hit the Earth at the speed of light or something like that. So I went through and I did the math on it, and there was a really huge asteroid that hit an area in Russia called Tunguska, and it flattened everything for miles and miles and miles. It was an absolutely massive explosion. It didn't hit. It was a meteorite that did not hit the Earth, but it did like an airburst explosion. How big was that? How big was the Tunguska? Not meteor, the explosion. Blast radius. Let me see how big this was. Approximately 830 square miles, or 2,100 square kilometers, roughly. So I went through and I did some searching, and I was like, okay, what was the estimated kinetic energy of this Tunguska meteor when it happened? And I forget what it was, but then I was like, okay, let me see, what would this 3,000-pound spaceship traveling at 99% the speed of light, what would it be? It was like 4 orders of magnitude bigger, if I remember right. 3 or 4. I was like, okay, so it would have just destroyed the Earth, right? Because it was 10 times the size. You're talking that, let's just say it's a linear progression, right? That 800 is going to expand to like 8,000, right? So that's a 1 order of magnitude change. This was like a 3 or 4 order of magnitude change. I was like, so we would have just basically just obliterated the Earth. That's cool. But that'd been funny. Yeah, it's pretty wild. Let me see. The Tunguska event. There you go. If you want some light reading, it was nuts. It flattened trees for hundreds of miles. It was a massive explosion. Make some of our nuclear weapons at the time look like wee babies. All right, let me see if I can get this to load now. Okay, cool. So it likes just having the blank parameters in there. Nice. Because now what we could do is... So we've got a tool to do this. To get the initial access exploit, generate Python code for a Dice Code Web Shell initial access payload. In fact, crap, I want to change this. And there's a reason for this. You might be wondering, like, am I just doing this for like completeness sake? No, it's because you have to remember all of these words are going to get converted to tokens in some way or another. Oh shit, we did call it initial access exploit. Okay. And so I want this resulting token to be as close to this resulting token to be as close to this resulting token. I want them in this giant hyperparameter vector space to be near each other to try and draw the language model's attention to it. So I need to go change that back. Let's Control Z. Exploit. Exploit. Oh wait, I already had code in there. Take that out. So this generates a... Let's see, generate Python code for a Diceco web shell initial access exploit. Boom. So the idea here is this would be reusable code that anytime we needed to access this again, pretty much all the agents should have access to the Python exec function. It could pass this code in, do a little bit of substitutions for the URL and the OS command, and be good. Actually, I take this back. Ah, crap. All right, Control Z all the things. Because I do want the target URL. The target URL, I do want embedded in here. Nope, take out the container, target URL. Yes, I do want that. This stuff can go away. We don't need volumes or containers, but we actually do want the target URL because this part here, we want the command to be able to be subbed in, but we actually want the target URL to pull from this parameter and be hard-coded. This is an initial access exploit specifically for that target. That's what we want. I just hacked the mainframe, and I'm the will of the bot after getting root. Oh, well, is the bot going to say I just hacked the mainframe after getting root? I have no idea yet, man. Eventually, I will have a front end for it. Like, we'll have some kind of a web front end. Maybe I'll do it in Svelte. I don't know. I think React is a little bit too bloated. But we'll have some kind of web front end to go interact with it and be able to get all this data back and forth. And that's probably going to be another big, huge code haul because I'm not a developer. I'm doing this to learn how to understand code development from the beginning to the end. Hacking on it and modifying it, yeah, Dude, I've literally done that since I was in grade school. But writing code from scratch, large code bases, I've never done. And I'm 41 now, so I was like, I figure this is an experience I should have. Call it NoobBot. Actually, there's a really cool game that Bobby Mack turned me onto, and it's called Night Team 4, Nite Team 4. And it was really fun. And it's like a kind of like a hacking simulator. Night Team 4. This one. And it's really fun, and it's a bit more like Hollywood hacking with some cool storylines to it and puzzle solving, but I liked it. And in this, you operate inside what's called the Stinger OS, which is like a military operating system dedicated to hacking, and you can access satellites and do all this other cool stuff. So that's why the agent here, the supervisor, is called Stinger, right? So I'm going to, once I actually get to the alpha release, where is it? Yeah, so once it gets to like its initial alpha release, the HackBot repository is going to be archived, and a fresh code commit is going to be moved over to, I'm probably going to call it like Stinger AI for fun. And it's an homage to 19.4. All right, this is actually, I think, how I want this, because I do want the target URL embedded. Yes. Upload evil shell. Yes. Okay, cool. I'm gonna go ahead and change this from evil shell to like web shell. Okay. I'm gonna change this again real quick. I'm gonna put one more example in here. I don't want this to be localhost. We'll call this. We'll make this target host. And I'm going to do the same thing over here. And rather than web shell, I'm going to call it like shell file. No, I don't like that. I think it's going to distract the language model if I do that. We'll just leave it like that. Yeah, we'll leave it like that. But unfortunately, that means I gotta go kill this and restart. Restart. Alright, so now, let's go back over to the exploit agent. So let's think about the flow of this again. So once the exploit step revisor validates it, it's gonna come up here. Did I have anything maybe in the exploit task I might be able to work with on this? Let me see. Okay, so an exploit task can only take on 4 states, which is new, working, validated, or failed. Let me see. So after it completes all the steps, yeah, I think what we're going to do is we're going to just basically check that last step. If the last step, which is the testing step, is confirmed, then we'll send it up to the task validator to actually see if it worked. Yeah, I think we'll do that. Crap, and I just realized we're out of time for tonight. I just saw the timer. Let's use that. Boop. Let me see if Shy Hat is still on, because if she is, we'll go give him a raid. And also, let me go plug your cyber doctor. I don't know him. But if you guys enjoy all the hacking content, go check out InfoSec Streams, because it's a really great website. Kind of shows you who's online right now. I'm actually not familiar with your cyber doctor. Let me go see what's he doing. Proceed. Let's see. Oh, cool. He's doing some Hack the Box. Heck yeah. Okay, cool. We'll go give him a raid. Let me see. Let me grab his thing. Guys, do me a favor. When you get in there, drop some Hack the Planets. Boom. Yep. All right. Unfortunately, guys, I know it's an abrupt ending, but that is where I have to end it. Everyone, continue having an amazing week. I want y'all to continue crushing it mode. We do not go weekly into the week. We go crushing it into the week. And you guys are doing a great job so far. Keep it up. Don't stop. And I will see you all on Saturday. We'll do some more Hack the Bot dev. We'll see if we can polish off the exploitation agent either on Saturday or Sunday. We'll see if we can get it. 57, love you, brother. Good to see your name in chat again. Yes, destroy the weak. The weak, not the weak, the time frame, not the people. Protect the weak people, destroy the weak time frame. There you go. Love you long time, Gumby. So, everyone, I think that's it for tonight. Thank you all for coming and hanging out and roasting me. You know I love it. Y'all are hilarious. Oh, I forgot. I have one more thing to tell y'all. Two more things, actually. One, I do have the blog post for the language models coming out. Oh, you know what? I didn't even set up the raid. I'm an idiot. Yeah, there we go. Start raid. There we go. So two things. I do have the blog post on the language models coming out. I'll post that on Twitter and up on Discord for y'all if you want to check it out. Like I said, it's a chunky read, but I think I did a pretty good job. And the snark is like dialed up to 11. So it makes the topic a lot more bearable. And the other thing I want y'all to remember is I love you. Peace.